right, folks, welcome to the afternoon session of the Asteroid Initiative Synthesis Workshop on crowdsourcing and citizen science. For the next few hours, we'll be hearing from folks that submitted ideas to the Asteroid Initiative RFI pertaining to how we might use citizen science and crowdsourcing to help us to find all asteroid threats to human populations and know what to do about them, the grand challenge topic. So I have a few introductory slides to walk through, and then we'll go ahead and turn it over to the presenters. We have 8 presenters this morning, most of which are joining us through Adobe Connect, so they'll be joining us virtually, but they will be available for 10 minutes right after their discussions for Q&A, and they will be calling back in at the end for the group discussion so that they're part of our brainstorm at the end of the discussion as well. To give a little context to what this session is specifically focusing on, for this particular session we're focusing on the Asteroid Grand Challenge portion of the Asteroid Initiative. So that is, the challenge statement is to find all asteroid threats to human populations and know what to do about them. It is the definition of grand in many ways, as folks in this room very well know, and folks watching from home also very well know. This fits in the broader Asteroid Initiative as one of the 2 parts of that effort. As you know, there's both the asteroid mission discussion that's going on at this initiative workshop, as well as the Asteroid Grand Challenge discussion that's going on at this workshop. There are 2 sessions that are specifically devoted to Grand Challenge discussions. This is one of them. The other is Next Generation Engagement that's going to be happening tomorrow morning. You can see in this visual representation of where the overlaps of these 2 efforts occur that the principles, the spirit of the Asteroid Initiative is in many ways that there are participatory engagement opportunities throughout both of these activities. So it's not just in the Grand Challenge that we're looking to engage non-traditional partners and seek innovative methods to try to approach the goals of that particular activity. They're also seeking to do that on the mission side of the house as well. And so we just came this morning from a great partnership and participatory engagement session at which Jason and the folks in attendance explored how partnership as a whole might be able to assist in both of the elements of the Asteroid Initiative. And there was plenty of discussion in that session about how whether or not participatory engagement meant public outreach, if it meant education, if it meant educating people about the real risks, if it meant a 2-way dialogue about policy priorities. What did that mean? What does participatory engagement mean? Or does it mean actually engaging individuals in the meaningful work of actually accomplishing the goal to find all asteroid threats to human populations and know what to do about them? And we made sure to note that that's exactly what we're here in this session to talk about today. We're here to talk about the meaningful ways in which individual citizens from around the globe can participate in the many elements of the Grand Challenge in a meaningful way to help us find where these threats are and know what to do about them. So moving forward, the goals of the session are to begin a discussion with the global community about crowdsourcing and citizen science in general as they relate to this Grand Challenge. And also we see this as one of the initial engagements with this particular community around creating a community-driven implementation plan. So at the last Asteroid Initiative workshop, after the event was canceled after the first day, a lot of the asteroid community stuck around for the second day and had a lot of great dialogue amongst themselves and with each other about what could be done in order to further the goals associated with the Grand Challenge by the community, as well as what NASA really needs to do from the community's perspective. And I understand it was a very rich discussion, and there were a lot of great connections formed and a lot of really good energy as a result of those discussions. And we see all of these discussions as being part of an intelligent way that we're trying to architect a series of interactions so that we're doing this together as a community. This is not something NASA is doing. This is something that we're seeking to do together. And we want to make sure that the implementation plan is crafted in that spirit and in that way. So today is just one of those discussions. It's a continuation of the discussion from September, but it's also the beginning of a set of discussions that Jason is leading as the Asteroid Grand Challenge Program Executive for the agency in the years to come. So we see this as a beginning. This session is largely a continuation of the beginning. We also hope to spend some time discussing overlaps and synergies between some of the ideas that are going to be independently presented today. And also, we hope that this can spur, the ideas presented today might spur additional ideas from the folks participating both in the room and virtually about other ways in which citizen science and crowdsourcing might be applied to the Grand Challenge. One other thing that we would like to encourage you guys to do today, and I'll come back to working definitions, you'll see there on the wiki, you'll see a link to a wiki, agcnotes.wikispaces.com. What we've started in the spirit of information sharing and in the spirit of continual learning and creating knowledge as we go is we've started a wiki with a lot of the things we already know about citizen science and crowdsourcing related to the Grand Challenge, and we're building on that document through these series of discussions. So any of you here today and watching from home can request access now to this wiki. It is something you have to request access to, and Jason here has the email up so he can request you right away so you can start contributing. We know there's already folks that are lined up to take notes from today in that wiki area, but it's also a great place to see kind of the baseline of knowledge that we've started to capture as well in this area of citizen science and crowdsourcing if you want to participate there. And of course, also feel free to tweet questions to us and comments and live tweet this whole session through using the Asteroid GC, GC standing for Grand Challenge, Asteroid GC hashtag. As far as working definitions go, there's a lot of, this is kind of an eye chart, apologize, there's a lot of words on this slide, but wanted to try to set the stage for what we mean by citizen science, crowdsourcing, and crowdsourced science, which are kind of three different concepts. So citizen science, you'll hear of a lot of different citizen science activities that have today that have already occurred, and we'll get some great lessons learned from them. But this is largely a paradigm where scientific research can actually be furthered by citizen contributions to that research. And also, individual agendas for research can be done based on an empowered individual to be able to do science and contribute to science on their own. And so you see a lot of citizen science in like the bird watching community. You see it in local environmental advocacy. There's this group called Public Lab that they actually distribute low-cost sensors for people to be able to take measurements in their community, in their local community, and take that data and make scientific conclusions from it that can help to inform them advocating locally for environmental justice. And so that is an interesting example of citizen science, where the citizen is the scientist. Crowdsourcing is a different flavor here. It's a process where the sum of the whole is that the sum of the parts is greater than the whole. So you're actually able to contribute a lot through individual contributions to a broader task. We do this at NASA through sometimes through challenges, like what we do on the NASA Tournament Lab and the Innovation Pavilion. But also, there's a lot of instances where crowdsourcing projects can involve individuals doing a bunch of mouse clicks, like on Zooniverse, individuals doing a bunch of mouse clicks to identify whether or not that galaxy might be a spiral galaxy or it might be a different type of galaxy. They help to characterize with the human eye and go through a lot more data a lot quicker than we might be able to normally in normal course of business. So that would be an example of crowdsourcing. And crowdsourced science tends to be an activity where you're crowdsourcing, but for the purpose of science. It's not necessarily individuals doing science on their own. It's individuals contributing microtasking to broader science. So there's slightly different ways of looking at the whole scope of ideas that we're going to be looking at today. After all the presenters share their ideas, we'll have some time for in-room discussion at the end, where I hope that we'll talk about some synthesis across the ideas, gaps that still exist, kind of use those initial ideas as a point to kick off from for other ideation. So with that being said, we'll go ahead and transition to Carl from the University of Arizona, and I forgot to introduce myself, so I'll do that real quick. I'm Jen Gestetic. I'm the Prizes and Challenges Program Executive in the Office of the Chief Technologist at NASA headquarters. And in that capacity, I lead the advocacy, policy, and strategy for the agency's prize and challenge programs. And then to my left is...
I am Jason Kessler. I am the program exec for the Asteroid Grand Challenge, also based at headquarters in the Office of the Chief Technologist.
So now you know us. And go ahead and transfer it now over to Carl, who's going to tell us about Spacewatch and the OSIRIS-REx Target Asteroid Citizen Science programs.
Okay, thanks Jen and Jason. I'm going to be talking about a few citizen science projects that we've been conducting at the University of Arizona's Lunar and Planetary Laboratory that are directly related to near-Earth asteroid research. And I'd like to also acknowledge Bob McMillan, who's the head of Spacewatch, and Tim Swindle, who's the director of the LPL, helping with this presentation. So LPL has mainly been at the forefront of asteroid research since the 1960s. A lot of pioneering work on asteroid photometry, whether it's light curve photometry, phase function photometry, even colors for taxonomy were not only conducted there, but were developed at LPL. We were the first organization with the Spacewatch program to discover asteroids routinely with a CCD camera. Before that, everything was done with photographic plates. The first place to discover small NEOs on the order of 10 meters or smaller. And the Catalina Sky Survey, which is another near-Earth asteroid survey similar to Spacewatch, has basically been the most effective and productive near-Earth asteroid survey of more or less the past 10 years. And is in fact the only asteroid survey that's ever discovered an asteroid before it hit the Earth. The one that 2008 TC3 that hit the Sudan back in 2008. So LPL's been involved in 3 projects. One project which is currently being developed right now is a collaboration between the Catalina Sky Survey and Planetary Resources, and that's something Chris Lewicki will actually talk about later on during this session. So I'll concentrate on a past project, which is the Spacewatch Fast Moving Object program, as well as the OSIRIS-REx Target Asteroid Characterization Project. Now, as I said before, Spacewatch was a group that used CCD cameras to discover previously unknown asteroids, whether they were near-Earth asteroids, whether they were main belters, Kuiper belt objects, even comets. It was conducted between 2003 and 2006. It was made possible with a grant from the Paul G. Allen Charitable Foundation. And really what they were trying to do is make up for the fact that most of the current asteroid surveys are very inefficient at discovering objects that are moving extremely fast. Mostly when you discover asteroids, they just look like stars that move over the course of half an hour or so. But if an object is extremely close, and even though this is actually a meteor in this picture, the asteroid will appear as a giant streak. And the software has always been very inefficient at detecting those streaks. And also, one problem is there's a lot of man-made artificial debris in orbit. So if you followed all of these streaks, you'd be wasting a lot of your time following stuff that turned out not to be a near-Earth asteroid. But the thinking was, as they were taking their data, if they made their data available online in real time, amateurs could log in and could pick up streaks that would be otherwise missed by the software. And it turned out to be extremely successful. They had over 300 volunteers over the lifetime of the program. On an average clear night, they had about 35 to 40 volunteers would log in and review images. It produced 43 confirmed discoveries, as well as recoveries of previously known objects. Some of them were artificial satellites, and there were a few that unfortunately got away. And most of the objects they found, one was as big as 1 kilometer, and some were down to tens of meters. And they moved about 2 to 16 degrees per day. And most of them were faster than 8 degrees per day. So they're finding a lot of small, fast objects that the software otherwise missed. There were some hard lessons learned. Remember, this is 2003, 2004, it was at Kitt Peak, bandwidth was an issue. So unfortunately, the volunteers weren't looking at the real raw FITS data as it came off the telescope. They were looking at compressed JPEG images. And if you know anything about JPEG images, they don't do a great job with linear features, streaks. So quite often, the amateurs at home would say, hey, I got a streak, that the observer knew right away it wasn't an asteroid, but the observer at home had no way of knowing that. They did have a good mentoring program with online interactive training that everyone had to take. But they found with time, as more and more people signed up, people just weren't paying attention to the training. And because there's a lot of things that mimic streaks in the sky. There's diffraction spikes off stars, there's galaxies, there's a lot of other things going on there. And so it ended up being where they were getting 1,000 false alarms for every real detection. And unlike most crowdsourcing, like the Zooniverse that Jen mentioned, where you could have people log in, look at the same galaxy, and over the course of weeks or months, the signal of noise will rise up, and you go, yes, that's definitely an elliptical galaxy. These objects, they basically had to be discovered in real time. You couldn't wait a week, you couldn't even wait a day, because the object's so close to the Earth, it zoomed past and it would be lost forever. Shouldn't say forever, but lost for a long time. And so you had to react to every object that was being flagged. And when you have 1,000 false detections going back to the observer who's at the telescope, who has to now keep up with this stuff, it became a really burdensome. And after a while, it ultimately required 3 full-time people working 8 hours a day on the program, and the project kind of collapsed under its own weight. So actual discovery, especially of very close small objects, especially the ones that ARM is interested in, you can't really crowdsource. You can citizen science it, but you can't crowdsource, which means stuff has to be done in near real time, and you have to find a way to get that signal noise level higher. Now, the project I'm currently involved in at the OSIRIS-REx mission, which, by the way, is a NASA-funded New Frontiers mission run out of the University of Arizona also with Lockheed Martin and Goddard Space Flight Center, as well as significant contributions from Canada and other scientists from around the world, will launch in 2016, go to a near-Earth asteroid named Bennu around the 2018-2020 timeframe, pick up samples from the surface, and return them back to Earth in 2023. And one thing we wanted to do was find out how could the average amateur help increase our knowledge of the near-Earth asteroid population, and in particular those objects that are good destinations for future robotic or human missions. Basically objects that are in orbits similar to Earth. Now, yeah, if we all had an 8-meter telescope in our backyard with a spectrograph and a CCD and thermal imaging camera, we can learn all we wanted to learn about these objects. But unfortunately, it's hard to get time on those big telescopes. They're far and few between, and surprise, surprise, most astronomers don't care about asteroids. Only a select few do. So the thinking was, how could the average amateur, say with a C8 in their backyard and a reasonably inexpensive CCD camera, how could they tell us more about these objects that we could otherwise learn with the larger telescopes? And it turns out there is one thing you can do, and that is observe the asteroid, do photometry, at what we call different phase angles. Now, phase angle is the sun asteroid observer angle, okay? If you think of the moon, 0 degrees phase angle is full moon. You're seeing the entire face illuminated. 90 degrees is half moon. 180 degrees is new moon, basically. And you get a slope. And this is actual data taken with the Target Asteroids Project. Most of this is from Patrick Wiggins, who's an amateur NASA ambassador up in the Utah area. And the slope of this line is directly correlated with the albedo of the asteroid. So by having this slope, you have the albedo. If you fit a model function, you get the absolute magnitude, which is how bright the asteroid would be at 0 degrees phase angle, and 1 AU from the Earth and Sun, so you normalize it. These two parameters together, you get the size. If you observe in different colors, like the traditional BVRI or the new Sloan filters that astronomers use nowadays, you get the color of the object, and that's a direct, I shouldn't say direct, but a pretty good correlation between the colors of the object and its taxonomy, whether it's carbonaceous, whether it's a piece of Vesta, whether it's an ordinary chondritic material. And the nice thing about this is you don't need high precision photometry, which you do need for, say, light curves, where you probably need a couple percent photometry to really get a good light curve. Here, 10, 20, 30, 40%, as long as enough people are observing over enough phase angles, you can beat down the noise. So you really can differentiate between dark asteroids and light asteroids, what their sizes are, and what their taxonomic compositions are. And for light curves, if they get bright enough, we ask people to do light curves. And of course, I help out by going to the bigger telescopes and kind of fill in the gaps when the object's too faint, or get, spectroscopy and stuff like that. So it really is a collaborative effort. Now, some of the lessons learned. First one, get the word out. Advertise, advertise, advertise. I mean, basically, there's a market out there, and there are amateur astronomers who have, reasonably sized telescopes with CCDs, and they're just looking for something to do. So go out to the astronomy magazines, go to the astronomy societies, and advertise. Make strong partnerships. And And we have partnerships with a bunch of different groups who all provide services. An important one is Peter Lake here, who works for iTelescope.net. Peter Lake got interested in citizen science because he was part of the Spacewatch FMO program. It inspired him to go out and buy a telescope, which he then made part of the iTelescope.net network, and is now doing target asteroid stuff, and has actually been working in classrooms with students from Australia, and I've had multiple times where I've actually done Google Hangouts. NEO characterization requires a worldwide solution. We have 184 partners from 28 American states and 30 countries spread all around the world. But you notice there are some regions that are lacking. And a lot of this, I believe, is a language barrier. You know, we do a really good job of producing English material, pretty good job of producing Spanish material, but there's a lot of observers in Russia. China, of course, is up and coming. Japan has always had astronomers, but a lot of them actually don't cross into the English-speaking astronomy societies. They have their own, and that's someplace we need to go to. The Middle East is developing a vibrant middle class. There's amateurs now coming out of Egypt and Turkey and Iran, so Arabic's starting to become an important language. So we need to start basically spreading our language base. So to make citizen science more productive, based on our experience, of course, is material non-English languages. Produce an online GUI where amateurs can upload their data directly, and that GUI can then reduce their data, producing photometry and astrometry in a rigorous, standardized way, and then that data could be fed to programs like us or the Minor Planet Center. Of course, work with as many for-profit and non-profit educational institutions as you can. Convince non-asteroid astronomers to try something different, like asteroids. And even though we kind of get this idea that citizen science is free, because the data is coming free, the analysis isn't. You still have a lot of person hours reducing the data. And so we found we need a lot of different specialties are critical for success, where we need a manager, we need a scientist to handle stuff, and then we need the data reducers. So it isn't necessarily free. And of course, citizen science, organized citizen science, is not new. It's been going on for over 100 years, especially groups like the the Association of American Variable Star Observers, British Astronomical Society. So there's a lot of experience and knowledge out there, and we just need to talk to them.
Great, thank you, Carl. Questions from the room? Go ahead. And we have microphones, so since we don't have a microphone runner, we're going to ask you guys actually in room to get up and go to a microphone if you have a question. Sorry about that. But for the Ustream, so everyone else can hear your voice.
The world is
The
waiting.
world is waiting.
The world is- I was just wondering, now, who is paying for, you said you have to have the staff, you have to have a manager.
Right.
Who is paying for all that in this?
Well, this project, it's run out of the OSIRIS-REx program, and it was run out of our education and public outreach, which now is communications and public engagement program. But to be honest, it's a lot of volunteer time that we're doing as a scientist, and Dolores Hill, who's working from the education side.
So it's University of Arizona has decided that this is important and that they're supplying the funds for the group to manage this activity?
Yes.
Great.
But there are things that unfortunately we don't have support for, like the upgrades, like producing online GUIs and stuff, which is something that the AAVSO does, where you can upload, you shoot a variable star, you upload your data, it finds which stars are which, it tells you where the variable star is, and it does the photometry for you. I mean, there's a little bit of manual interface there, but that's something we would really like for astrometry and photometry of asteroids.
Other questions? Do we have any questions from social media?
I have not seen any questions come in on Twitter or Ustream.
Okay, well, I have one, Carl, where other folks are thinking. So if today you were redoing Spacewatch, what type of file formats would be easier for folks to actually, not JPEG, for folks to actually be able to do the work that you're asking them to do? How would you do it today?
Today, I would actually just give them access to the raw FITS images. Nowadays, I mean, FITS browsers are pretty common. You just give them the data and let them blink. Basically, let them use the tools we're using. Of course, you can simplify it, but basically let them use the tools we're using.
So a question came.
Okay, go ahead.
So a question came in from Ustream. Any plans for a training program?
Yes. And in fact, one of the groups, if I go back, one of our partners, ISAC, which is the International Astronomy Search Collaboration. We actually run a program with them where right now it's an asteroid discovery program where we advertised it in some of the local, some of the astronomy magazines and some of the astronomy societies and got 40 people to sign up where they actually were taught how to discover asteroids on data that was taken with a 1-meter telescope. And the plan is to expand that to where we'll get data that's taken of our particular near-Earth asteroids that require physical observations and give people not only the tools and the software but also the training and how to actually reduce their own data. And of course, if you join the Target Asteroid Program, which, right here, we will mentor you. We have no problem helping. I mean, we know most people, this is their first time, and we all had to learn at some point, so we have no problem helping.
A follow-up question, real quickly. You said one of the things that didn't work well with the fast-moving object was that there was a training, and then over time, people fell off the wagon.
It seemed like, actually, over time, the people who were joining late didn't seem to follow the training.
Got it.
For some reason. I don't know if it's because the really interested people joined up first, and then there was a different subset of people joining up later, or they saw discoveries being made, so they jumped in.
So is there a way to pull that apart, and as you're talking about adding training or making it available so that that doesn't get repeated, or to prevent that from happening again?
I mean, one thing you might have to do is have a test where you throw up stuff and you go, okay, here's 20 objects. Which ones are the real objects? Which one are the real asteroids? And the ones who pass, move on, and the ones that don't, practice, practice, practice.
That's a mechanical Turk approach, so Amazon does that.
Yeah, and we'll take 2 more questions, Steve, and then we'll take a second question from the room, and then we'll move on to the next presentation. And at the end, we'll have discussion at the end. If you guys want to put those questions down, we can make sure to have that conversation with Carl.
But the talk that Crystal Wiki is giving later on in the session will actually address basically looking at this same problem that Spacewatch had using crowdsourcing from a different angle.
Yep.
So,
Yeah, I just wanted to extend on what worked and didn't work. Is there any sort of curation of the community that you're doing? Or like, do you run little sprints for tonight we're doing a contest to see who can find the most, or there's a lot in the model of crowdsourcing that seems that we could apply to this to really increase your crowd from tens to hundreds and thousands, and 2, to increase the training.
Right.
There's just some best practices, I think, in community curation that could start to happen in some of these various communities.
yeah, and that's kind of what's going on when Isaac's running their campaigns, their discovery campaigns. They break everyone up into 3-person groups.
Right.
And though there's no money being won, they kind of compete against each other.
Sure. And there's a lot that's about prize levels or even just little medals and whatnot that you get that are being used in a lot of other communities that might be a nice model.
But the thing that really helps is just interacting with the volunteers. I mean, let them know their data is appreciated. Tell them, what to observe. Tell them that their data was good, which it usually is, and if it's not, you tell them how to improve it. But basically, let them know their data is being used. It's the most important thing.
I know some hackers use online gaming to try and get around to teach their AIs how to get around security protocols. Is it possible to use a similar tactic to teach the AIs how to better recognize the faster moving objects?
Yes. And in fact, I think Chris Lewicki's stuff will go into a little more detail on the project that is a little more along those lines.
Great. All right, thanks, Carl, very much. And we should have Tim on the phone. Tim, can you hear us?
I can hear you fine. How about me?
Yep, you're a little muffled. So if you're on speakerphone, take yourself off of speakerphone, but we can hear you.
All right, let me take my... How's that?
It's great. All right, so we're going to just go ahead and put up your presentation. We can see you now. And you can go ahead and get started, Tim.
All right, the one thing I'm not seeing is the way to change the slides here, but maybe that will appear. Oh, I see it. Okay, good. So I'm Tim Axelrod. I'm the EPO scientist for LSST, the Large Synoptic Survey Telescope. And I'm going to be sketching an idea with actually very similar goals to the project that you just heard about from Carl. But as you'll see, it's considerably further in the future. So I want to begin with a quick overview of LSST itself. It is the Large Synoptic Survey Telescope. It's going to be based in Chile. And the notion is that it's a telescope which conducts for 10 years a survey in which it scans the entire visible sky every night that it can. So the telescope, as you'll see here, it's pretty big. It's got an 8.4 meter primary. The thing that's unusual about it is that in conjunction with this very large primary, it also has a huge field of view for a telescope like this, so 3.5 degrees diameter. And it has a single instrument, which is a 3.2 billion pixel camera, and it takes images very fast. It takes pairs of 15-second exposures as quickly as it can, which means that it moves on to the next field about every 40 seconds. And it comes back and covers the same bit of sky sort of every couple of nights. So it just operates this way. It scans the sky continuously, essentially, for 10 years. So part of the project, as you'll see in a few minutes, is that it processes the data and serves it both to scientists and the public. And the data that it produces covers several different areas. It sends out alerts on events, we'll call them, which means essentially anything that changes on the sky. This could be a variable star changing in magnitude. It could be the appearance of an asteroid in a field that we don't know about. It could be a supernova, many other things. So it sends these out with very short latency for purposes of follow-up. So within 60 seconds of something like this being detected, it's sent out as a VO event and goes out over the network. And then there's a very extensive database, catalogs of all the objects that it finds on the skies and what their properties are. So this means magnitude, shapes in the case of galaxies, light curves. And then, of course, there are the images themselves. So one thing about LSST is that education and public outreach, EPO, is an integral part of the project. So it has been from the beginning. And so my role in the project at this point is to be the kind of science guide for what EPO is going to do. So the LSST is, we hope, just on the threshold of beginning construction. It's in this year's President's budget. We all know that that's a bit short of a guarantee of beginning construction, but there you go. So if things go as we hope they will, science operations will begin in 2022. So we have some time to get all this together from the EPO perspective. So I've touched on this a little bit already, but I'll just emphasize that the LSST is a different kind of telescope than you have probably encountered before. It really is an integrated survey system rather than just a telescope. So the observatory, the telescope, the camera, the data management system are all built to work together, and they're built really for a single purpose, to support this LSST survey. And I should say that the survey itself is designed to support many, many different science cases. So dark energy, galactic astronomy, there's a large number, and of course solar system science, which is our interest here. So unlike the usual telescope, there's no PI mode, there's no proposal, there's no getting time and going to the telescope. The thing is just a machine which runs and produces data. So from the perspective of the normal user, you don't really use the telescope, you use the database. And this is of course the spirit that the Sloan survey has begun. So it's very similar in many ways to Sloan. Okay, so I think you've got the message that LSST really is the database rather than the telescope itself. So we see citizen science, and possibly thinking back to Jen's definitions in her intro, this definitely should include crowdsourcing as well as citizen science. But we see both these things as being integral to the overall process of how LSST works. So here's a cartoon that kind of shows you how this goes. If you think of this as the stream of all the data being collected by LSST, you can say that there's some large fraction of the data which is basically understood. So, it's some Cepheid variable going up and down. We know what that is. But there also are aspects of the data, and I would very much include asteroid observations here, as things that, while they may be understood, they also need human intervention, largely because our algorithms are just not good enough to deal with them. So here you have your citizen scientists down here dealing in some way with this data that requires human intervention. And this touches on a question that was asked a few moments ago. One of the functions that we see to this is not just understanding the data that wasn't understood before, but also as sort of a back channel training algorithms so that this process here will be more efficient than it was before. So moving on to the main subject here, how can we use citizen scientists for asteroid detection? So that the main problem here, especially compared with something like Spacewatch, is just scale. So the LSST every night will observe something like 1.1 million asteroids, and this does not include false alarms. You'll recall that Carl said with their experiment with citizen scientists, they were getting 1,000 false alarms for every real detection. We hope to do much better than that, but it's certainly not going to be one-to-one. So in any case, you have millions of things to look at every night. And personally, I think that this is too many to have citizen science just look at every single bit of an image that may or may not have an asteroid. And I think there's a very good prospect that we can have algorithms that work very well at the pixel level so that we don't need to do that. But the real problem comes in at higher levels. And to explain that, I have to give you a little cartoon of how at least the LSST processes asteroid data. So what we try to do is observe every field twice in a night. So you have a set of pairs. And the software is quite good at linking the pairs together to form what we call tracklets. And then if it's able to, it can merge tracklets from a single night to make longer tracklets. But the real problem comes when you are putting together, you're linking together data that goes over more than one night. And, in this cartoon, it actually looks like a pretty simple thing. You can see, obviously, where the track is. But remember this millions of detection issue. If you actually plot out the LSST detections over several nights, it is just an absolute chaotic mess. And deciding which things go together to form a real asteroid track is not easy, even for the best software that we have. So enter citizen science. The important thing to know here is that the computational complexity of this track linking problem grows exponentially with the number of detections in an image and with the speed of their motion. And you'll recall Carl talking about objects that move very, very fast, and those, of course, are also the ones that we're most interested in. So the more of them there are, the faster they move, the harder this is computationally. So the current algorithms are actually very good at producing candidate tracks that are plausible but whose correctness is far from assured. And once you've reached that stage, it's not clear how to do better algorithmically, but it is pretty clear how to do better if you're a human sitting at a terminal in front of the data. So there are a number of other information sources that a person can bring to bear that are not so easy to do algorithmically. So real orbital dynamics, the algorithms that we use of just for computational necessity can't use fully realistic orbital dynamics. They don't know about the systematics of the solar system population, so they can't say how plausible some track would be. They don't currently look at light curves, which is one of the most fruitful sources of saying, is this a real track or is it not? Because if something's intensity changes from night 1 to night 2 in some unrealistic way, you know that's probably not a real track. And then finally, of course, there are observations from other telescopes, and with the sort of infrastructure which is being put together around VO events, the ability to process observations from other telescopes is going to become an increasingly easy thing to do. So I claim that with the right sort of tools, it's going to be practical for citizen scientists to undertake this kind of analysis. And by doing so, they can greatly increase the efficiency of the entire man-machine system for detecting and cataloging NEOs. So I just want to conclude with a few thoughts about what these tools might be. And I first want to point out that there is a very different application area called wide area motion imagery, which has many problems in common with ours. And it's much better funded than we are because it's all essentially security-based or security-oriented. And essentially the problem is you got a bunch of cameras looking at things that are moving, and you want to be able to track objects across them. And I know I'm running out of time, so I don't have a lot of time to go into what that entails, but I think the point is that they have a lot of tools that are under active development, and we can learn a lot from them, and they're very well funded compared with us, as I said. So the cartoon that's at least in my head is that when the citizen scientist sits down in front of LSST data, that he or she will have a number of tools at his disposal, and this would include the ability to examine the images, the ability to look at light curves, and the ability to interactively fit orbits. And so the role of the citizen scientist is to use those tools to draw a conclusion about whether a candidate track is likely real or not. So this is something which is clearly going to take a lot of training. Think about Carl's talk again. But I think it will be challenging and fun and will actually motivate real citizen scientists as opposed to simply mouse clickers. And I think it will be good for the whole community. So I'll finish there. Thanks.
Okay, so we'll start with any questions from the room while Heather's looking on social media and on the chat. Okay, I have one. Tim, are you guys considering doing some of the phase curve work as well that Carl had mentioned, or is that something that you guys evaluated and decided not to do because of the other projects you have lined up for citizen science?
No, we've not really gotten into the details yet at all. As I mentioned, this is a sketch rather than a real plan, so I actually wasn't even aware of that way of processing the data. I'm not a solar system scientist, I hasten to add. So that's a very interesting thing. It sounds like it would fit in perfectly.
Follow up on that question. I mean, with the amount of data that you're going to be producing, you'll have phase functions for every asteroid in the main belt, most of the near-Earth asteroids. It'll greatly increase our knowledge of the sizes and albedos of these objects. Especially since even if you do go to a Spitzer and get thermal infrared observations, you still need to know the phase function and the absolute magnitude. Without that important data point, the thermal observations really are kind of hamstrung. So doing phase function photometry with LSST would be great.
Yeah, that's good to know. Thanks.
Another question in the room? Go ahead.
How deep a magnitude does the telescope and sensor detect?
Oh yeah, good question. I should have mentioned that. So, single frame exposure has limiting magnitude of about 24.5. So, and of course, most of the things that we detect will be close to that limiting magnitude. So, these are really tough to follow up with amateur level telescopes.
Another question, Tim, from me is, what challenges do you think that building a citizen science program within a large survey like this face? Are they technical? Are they organizational? Are they capacity? What type of challenges are you designing your program to kind of counter?
Well, at this point, we're really trying to design a platform which can support a wide variety of citizen science projects, because, of course, we realize, beginning operation in 2022, the problems that are interesting for citizen science then will be different than they are now. So our big focus is on the architecture. But certainly the challenges that we face, I think, are not unique to us in this field. I think it's largely sociology. I mean, again, listening to Carl's experiences with people being trained but not actually applying their training, I think those are probably going to be the real challenges. Capacity-wise, we're certainly thinking hard about using the cloud as a way to give us the sort of elasticity that a project like this needs. So, again, I think the sociology is probably the hardest.
Okay, great. We have a question from social media.
The question that came in was how many tools now developed?
Well, I guess to be completely honest, I guess I would have to say that there are 0, except that if I go back to my list of tools here, wherever it went to, I guess it was already there. Something like, image examiners and light curve viewers and orbit fitters, they all exist as tools. It's just that we haven't yet integrated them into our EPO prototype, really, and that's sort of one of the things that we're going to be doing over the next few years.
And how small of objects are you going to be able to see?
Well, you tell me. I mean, it's sort of it's magnitude limited for us, so 24.5. So.
Okay. Any other questions in the room?
I think that we can get sort of 80% of the way to the federally mandated 140 meter diameter requirements. That gives you something of a scale.
Okay, great. Thanks. Jason?
Yeah, you've got an incredibly thoughtful plan laid out here with Science Ops not until 2022, as I recall. How are you keeping this all together and building momentum and preparing for this incredible amount of data that's going to be coming?
Yeah, well, excellent question. I, of course, should mention, which you probably are already aware of, that we didn't actually begin this project thinking we would be on the sky in 2022. It just sort of, developed that way. So maintaining the momentum is always a challenge. My own hope is to begin prototyping a lot of this stuff as soon as possible and tying it into a real data source, which of course will not be as large or probably as deep as LSST, but will still let us develop the tools and get our feet wet and understand what the real challenges are. So I think prototyping is a large bit of the answer of how do you keep the momentum.
Okay.
Great. Well, thank you, Tim. And I believe the next presenter, Ray Picard, should be on the phone. Ray, are you there with us? Ray, we can't hear you if you're on mute.
I muted him.
Yeah, sorry, you were muted. You didn't mute yourself. Hold on one second, Ray. Okay, Ray, we should be able to hear you now. There we go, great. Go ahead, Ray.
Yep. Okay, I'm just waiting for my presentation to pop up there. I am having a few internet problems this morning. There are thunderstorms around us and they keep knocking out my internet every now and again, so fingers crossed that we can get through this. Now, just waiting for my presentation to pop up. But what I am talking about this morning is actually small grants for observatories to be able to sort of participate, and some of the ways at which we can involve the community in asteroid research and get them involved in some of the searching and things like that, which covers that first slide. Now, a brief outline of the presentation is a little bit about what we do here, answering the questions. Most of the information for the paper I submitted was based on question 6 of the Asteroid Initiative, in particular, addressing some of those things. Some of those things I put up there will actually change in this presentation because even over the past few days, things have really moved ahead so far as what we're doing here with the asteroid proposal. The observatory here has been very keen to do asteroid research for many years. It's actually a small privately operated observatory, funded pretty much by donation only entry, the occasional small grant for equipment, but its primary role is for public outreach and education. I'm an educator myself. I teach in schools and that when I can. And our primarily our research goal, and what I'm probably best known for, is my work on meteorites, research work on asteroids and comets, as well as an imaging program we have to stimulate public interest in things up there in space as well, which we post on our Facebook page. Now, the questions, as I said, most of my response is based on question 6 of the Asteroid Initiative. And in particular, some of the things I wanted to emphasise from that paper is the importance of a dual hemisphere coverage. Most of the asteroid searches are located in the northern hemisphere, but asteroids can approach from any direction, so therefore we need some sort of coordinated approach to cover both hemispheres. And in particular, I know that there is a vast amount of equipment out there in amateur hands as well as some of the professional hands which will be able to help in such a venture. Particularly so far as, I know I've captured a few small asteroids on images and not known whether or not they've been asteroids, and finding that methodology of being able to check those fairly easily. Most of that sort of observational stuff I covered in my first talk in the first conference a few weeks ago about the methodologies and things like that. But I'm very interested in the Target Asteroid project, which was talked about a bit earlier on, because I feel that was something that we could probably link into, particularly in light of our negotiations with the university, which I'll mention a little bit later on. Now, grants. Now, because international rules don't allow monetary grants, which is probably a good thing to other countries, what I'm thinking about when I talk about grants is actually grants of equipment. I know Target Asteroid use a plane wave telescope, and I've actually been inquiring about the cost of some of those so that equipment can be shared around the world. If we spread telescopes far and wide across the globe, it ends up being a much cheaper option than space-based telescopes. We have tried in the past to establish an asteroid search telescope here. We had a commercial enterprise fund a half-metre Dow Kirkham telescope, and that telescope was constructed, but due to the global financial crisis, the last payment on that telescope was unable to be made, and that telescope still to this day, some 4 years later, resides in a crate down in Sydney, still uninstalled, unused, and waiting to arrive at some point. Now, we do try and attract grants, but being privately operated and a fairly small facility, generally commercial enterprises aren't particularly interested in giving us grants because they don't see the value for money, I guess, in funding a small facility. They don't really get their advertising dollars, I guess, from saying that we sponsor such a thing. So most of our grants have been state and federal government grants, but in particular, what we feel is that a little bit of opportunity lost so far as the research work and that we could do. Now, involving the community, operating on a donation basis means that I access as many general public to the observatory as we can get, as well as school children. Being an educator, one of the things I do is write educational programs for students, and I've just actually worked on one that's going to be used throughout New South Wales on space, and I've actually included asteroids in that. As I mentioned earlier, the dual hemisphere coverage, and one of the things I'd like to set up is to have a telescope here, internet accessible, because while it's nice here in Australia today in US schools, so that if there's any asteroid work to be done, there's a possibility of being able to link it to the US schools in that respect. And perhaps if we can form a partnership with a US-based telescope, a reciprocal arrangement could be done there. As I mentioned earlier, I do a lot of my work on meteorites, and this sort of work strongly links to the meteorite work that I do in classification of meteorites. So the asteroid work and meteorites kind of link together. As I mentioned earlier, we've actually, during the break between conferences, we've actually started networking and have ended talks with the University of University of Canterbury over in New Zealand to try and do a joint proposal and a joint effort in researching asteroids. One of the things they're going to be doing is using their 1 metre telescope to actually search, and one of the things we'll be doing then is, in particular, follow-up work, triangulation, and that sort of work that way. I don't think with the smaller telescopes and that we have here that we've discovered too many, but a lot of that follow-up work, I think, is an area where amateurs can fit in. Another thing we're doing is tomorrow I have a conference here in Bathurst with the community talking about asteroids and the threat they pose. So we're out there doing a public outreach already, so talk on that tomorrow. What can be done in the short term? One of the things I think is needed is some sort of alert system. If an asteroid is discovered by any of these sort of telescopes and that out there, needs to be sort of an instant system so that the follow-up observations that can be done, something established either by texting to phones or email alerts or something like that. One of the things I am worried about is the momentum after this conference, that maybe momentum dies out and that everything falls apart at the end of this conference. So I really want to make sure that after this conference in particular, that these networks and momentum keeps going and communication, all that continues. One of the places I think where places like myself can actually help is in the pilot studies, particularly for larger ones, testing some of the things, like if you create an image or a set of images, how quickly can people pick up whether a streak is an asteroid or not. So being able to be used for that. And some of that will require training, for particularly amateurs in order to know what they're looking at. And I think that's an area where not only grants for equipment and that can help, or equipment provided, but grants can also be in a form of training. And my point there is that NEOs aren't just a threat to one nation, it's actually a worldwide threat. So some of the benefits that I can see, particularly towards our facility, is the media exposure. The media here are frantically trying to get an interview with me about this NASA conference and the asteroid talk I'm doing tomorrow. Being able to test some of these systems before they go ahead, the extension to our public awareness and educational program, and in particular the way I want to try and link in schools into this program. So far as the technology and communication systems go, I think if we can establish a network of like systems around the world, which is, like I say, why we're looking into a plane wave telescope, is so that the technology and systems are like around the world, so it simplifies the software if we want to do internet connections and things like that as well. And like I say, closely linked in with the work that I do on meteorites, the work on asteroids and that as well. So finally, I'm happy to send copies, since this was a very brief overview of the paper, the full paper to anyone wanting them. I'm always open to suggestions and comments and things like that. My email address is up there. And there's a Facebook page for the observatory where we post some of our image, which includes some of the images of NEOs and things like that we've taken in the past. you. I'm open to questions.
Thank you, Ray, very much. I'll start us with the first question. In general, Ray, what do you think could be done in general to start building more of a community of observers and amateurs in the Southern Hemisphere in general? We saw earlier in Carl's presentation that there are significant kind of gaps in coverage in that part of the globe, and for your country specifically, and maybe some of the other countries that you've initiated collaboration with, like New Zealand, what might be the unique kind of cultural or education things to take in mind to recruit more observers from that area of the world?
Well, we've actually started. I've contacted both the state and federal governments and outlined the proposal pretty much as I did in the papers to the conference, and had meetings with federal members, and they're really quite keen about particularly maybe offering some funding towards the project. And I think to letting the public be aware, like say the Russian fireball over Chelyabinsk earlier this year, it happened so remotely from Australia. We haven't had a significant meteorite fall since about 1969 here. And I think it's way out of the public mind. So actually establishing some of these public education programs and getting out there amongst the people, letting them know what's happening so they can support it. And particularly for, say, us, it's a fairly cheap option to do. Like we're looking at probably needed maybe $25,000, which the federal government says is peanuts. I'm glad it's peanuts for them. To establish what would probably be a very good follow-up size telescope here. So I think if we can get that support and that, via the government and just letting the general public know, I think particularly the NASA brand, if we said we're involved with a NASA partnership here in Bathurst, that would really stimulate public interest, particularly regionally here. And I think that would also stimulate other grants from energy companies and communication companies and things like that, if they could see that their money was being spent on a research project that had a NASA tag attached to it. I think that is where I think it could go. Anything to do with NASA, the public's interested.
Great. Question in the room? Carl?
Ray, this is Carl Hergenrother. It's good to talk to another target asteroider. Have you considered trying for a Shoemaker grant?
One of the difficulties I do have is being privately funded, and even though we operate on a donation basis, is that it makes me exempt for a lot of grants. I haven't tried any overseas grants. I'm really trying to sort of seek Australian sponsorship, but no, I haven't sought one of those. One of the things I'm looking for is actually biting the bullet and setting the observatory up as a standalone educational entity, I guess charity as such, where I'll step back from it and basically gift my stuff to the observatory in trust and run it that way, which will actually aid me in grants. But I haven't sought any overseas ones, no.
Yeah, just for those people who aren't aware, the Shoemaker Grant is a program that's run through the Planetary Society, and it's completely private, and it's for amateurs or even small universities to apply for grants on the order of $5,000, $10,000, $15,000 to upgrade their telescope to support near-Earth asteroid research. So, Ray, I would actually suggest look into it. I think the proposals are due in the spring, and it's something where you might be able to get some money, some seed money to help upgrades.
I'll very much inquire into that, because like I say, we scratch around for as much as we can.
Do we have any questions from social media? So Ray, I have another one for you. How well do you feel plugged into the global reporting community? So when your observatory makes observations on asteroids, do you guys report them into the Minor Planet Center?
I've got to admit that one thing I did talk about in my previous conferences, we do actually feel fairly remote here. And I have to admit the Minor Planet Center is almost, I'll use the word frightening, I guess, to use from an amateur point of view, for that fear that you're trying to establish yourself as a serious research place, and if you make a false submission, that how that might look upon you. We do feel I guess, somewhat somewhat disconnected from the world community in that way, but hopefully by establishing links and conferences like this where we can network and that, I'm sure some of those barriers will be broken down, and particularly to follow-up observations. If I find something, to be able to send that off to someone in another part of the world where it's night time, if I'm reviewing the data during the morning, say, can you check up this, please? I think that's going to benefit us more in the long term.
By the way, it's Carl again. Yeah, the Minor Planet Center is a pretty frightening place, but you'll find that they're actually not that scary. And Jose Galachi, who's going to be talking later on, is the person to talk to. They'll definitely help you with your observations.
Yes. Yeah, well, I'm encouraged that I will be submitting more of those sort of targets and that we do find, because one of the things that I hope to do is here, particularly with our education program, is get kids involved in searching for asteroids and searching for supernovas. And we can either do that in a targeted way where we can actually search for the asteroids themselves, or hopefully have them turn up as random objects when we're imaging other things. We might be imaging a galaxy and an asteroid turns up in there. And to encourage students in that to be able to report their finds in that as well. So there's some of the things that we're hoping to do.
Great. Thank you very much, Ray.
Thank you.
All right, and before we turn it over to Peter, which I believe he has a video for the first part of his presentation, I just want to give 30 seconds on kind of the flow of the presentations that we're hearing today. So we started off a bit with and you'll notice most of the discussion today is about ground-based observations, and using ground-based observations to try to increase our knowledge of the asteroid population, the NEA population. There's also significant space-based observation tools that are in discussion, and some have already occurred, like the NEOWISE survey that was done by NASA. So there's also space-based observation and data from those observations that might be crowdsourced as well. But there's either the ability for citizen scientists to physically take new measurements, either using their own equipment in their backyard or renting equipment from people like SLU or iTelescope, or going to, like Ray was talking about, going to their local observatory and partnering with a mentor scientist like Carl and actually getting walked through at a big observatory how they can actually take some measurements off a big telescope. So there are those folks that can actually take new observations and contribute those to the data set. But then there's also, and we'll hear later about more of these ideas, there's also then, with all that data that we do have, how do we more effectively mine that data, both for algorithms and machine learning, and also to extract new information from that data through citizen science in that way as well. So you don't necessarily have to own equipment as an amateur to participate, which leads us into Peter Barrett, who is an amateur astronomer himself, who wasn't taking measurements with his own equipment, but instead was using existing data to try to hunt for comets, actually. We'll hear more about his experience in the video that we're about to show. We will take a break after this. It's not written on the agenda, but we will take a break after this presentation for 10 minutes. Then we'll come back and we'll do the final four before we take another break, and then we enter into the group discussions. So just to give us a pulse check on where we're at. And with that, Peter, do we have Peter on the phone? Did Peter not call in, Aaron?
Yeah, he's
Okay.
been writing on a
Okay,
couple questions.
all right. So Peter, while we're playing your video, if you could call in so that we can make sure that folks can have an opportunity to ask you questions after your video plays.
Hello everyone, and a warm welcome from Melbourne, Australia. My name is Peter Barrett, and I'm an amateur radio operator, podcaster, and citizen scientist. First, let me thank NASA for this opportunity to present my submission to this forum, and also to the other forum participants who gave some useful feedback in a Google Hangout we had a few days ago. I've refined my proposal slightly in light of those comments. My proposal is drawn from my experience with another citizen science initiative called the Sungrazer website, which is funded by NASA and ESA. I'd like to take a moment to explain how that program works. For the past 17 years, the SOHO spacecraft has been taking photographs of the region immediately around the Sun where Sungrazer comets fly by. The Sungrazer website makes these photographs available for download to the general public. It also provides a suite of comet hunting tools and a comprehensive comet hunting guide. Participants, including children, can register, download images, and then examine a series of photographs to look for a dot moving in a straight line and at a constant speed. If they find such a dot, and it's clearly not a star or a known planet, they can record the object's coordinates in a series of images and then fill out an online comet reporting form. That report is then checked by the SOHO site webmaster, Mr. Sungrazer. The first person to find and report an unknown comet gets credit as its discoverer. It's a great program, and to date around 100 citizen scientists and enthusiasts, including myself, have reported in excess of 2,500 confirmed comets. Now, it's really easy to spot a comet, but it wasn't until May 2013, after 4 years on and off, that I was able to be credited as the discoverer of a comet. The reason? The cameras aboard the SOHO spacecraft only take around 240 photographs a day, and a new comet only comes along every couple of days. So competition to be the first to report a comet is intense. One personal disappointment I had about the program was the fact that comet discoverers don't get to name their comets, because the International Astronomical Union has a rule that says that discoveries made using space-based telescopes get named after the telescope. However, this rule does not apply to discoveries made using ground-based telescopes, and that's an important point to note when designing an asteroid identification program. It's clear that the Sungrazer program is a proven success, and my submission is that NASA would create a citizen science program to find asteroids based upon the Sungrazer program. In my proposal, NASA would have a large fleet of ground-based telescopes scanning the areas of the sky that are not currently being scanned by current sky surveys. It could then provide the photographs online in a special website, along with an asteroid hunting guide, some software tools, and a reporting form. The big difference, though, is that now the first person to identify and report an asteroid would not only be credited as the discoverer, but would also get to propose a name to the IAU for the object. This would truly be a revolution in astronomy and citizen science. Citizen scientists, enthusiasts, and most importantly children, would have the opportunity to discover a celestial body and name it. No longer would these benefits be the exclusive preserve of professional astronomers and those amateurs who can afford expensive telescopes. The participation of children in this program is very important. How better to encourage children to study maths and science than to get them to use their maths and science skills in a practical setting and reward them with the ability to name a patch of the night sky. I think that the opportunity to name a celestial object would be a great motivator for citizen scientists. When I tell people about my comet discovery, their first question is usually, "What did you call it?" I'll be keen to look at the public feedback on Twitter and elsewhere to see the public's opinion as to whether they think that the opportunity to name a celestial object is important or not to them. Now, concerns were raised about people who might try to cheat the system, for example by the use of multiple accounts. I've given this some thought, and I think that that concern can be addressed through a range of measures. First, there needs to be lots of images made available to everyone each day. even hundreds of thousands of sequences of images if possible, so that any one person could not review them all. Next, each individual would be limited to one asteroid discovery only during the life of the program. One exception to this rule could be that you could be credited as a discoverer of another asteroid only if the images are older than 1 month. This would mean that the asteroid discoveries would be shared around to as many people as possible, whilst people who have found an object previously would still have a chance to find another asteroid in archival images. Had such a system been used on the SOHO website, there would have been at least 2,500 separate discoverers, not 100. There could also be an additional rule that says that anyone who tries to cheat the system by signing up for multiple accounts or using false names would have any and all of their discoveries annulled if caught. Each discovery would instead be credited to the next person to report it. Each asteroid report could first be peer-reviewed by other citizen scientist volunteers. Where the majority view is that the asteroid is a real undiscovered object, the report would then go on to the Asteroid Initiative webmaster, who would schedule further observations, confirm that the object is a new undiscovered asteroid, calculate its orbital attributes, and then submit all this information along with the discoverer's proposed name to the IAU. This system minimises the number of paid staff that are needed to administer the program and thus its cost. Now we come to the final question. What do we call the Asteroid Initiative? It needs a name and perhaps an acronym. Thanks for listening to my presentation, and roll tape. What if anyone, even a 12-year-old child, with their parents' permission, could go online, participate in a citizen science program, find an asteroid, be credited as its discoverer, and get to name it? What a life-changing experience that would be. Well, now there's an Australian proposal for just such a program, iNectarine, the initiative for near-Earth comet tracking, asteroid risk identification, and novice education. And who better to take you to the stars than the people who took you to the moon? NASA. Lots of telescopes, taking lots of photographs of the night sky, made available through the internet for everyone to study, to find undiscovered objects that might one day threaten the Earth. So, don't be surprised if one day a 12-year-old child, with their parents' permission, saves the world. Now, wouldn't that be cool? Hello everyone, and a warm welcome from Melbourne, Australia. My name is Peter Barrett, and I'm an amateur radio operator, podcaster, and citizen scientist. First, let me thank NASA for this opportunity to present my submission to this forum, and also to the other forum participants who gave some useful feedback in a Google Hangout.
Quite talented, and also I had a friend in France, Faiza, who gave me a few suggestions, so I just want to acknowledge her input as well.
Well, great job on the video. Everyone in the room was loving that, so we really enjoyed it. Thank you. So with that, we'll go ahead and turn it over to questions that we have for Peter in response to his video. Peter, I can start with a question. You mentioned kind of a toolkit that you thought would be useful for a NASA asteroid hunter type of activity, similar to the comet hunting activity, that included some basic training, the images themselves, and the reporting form. I was curious what you, as an amateur astronomer, what are the tools, the minimum tools that you think that you need in order to be able to contribute to a program like that?
Well, first of all, basically what they've got on the Sungrazer site is a very good example of what's needed. First of all, you need a general guide that actually sets out what a comet actually looks like on a series of photographs. The main rules run along the lines of you're looking for a dot moving at a constant speed with generally a constant brightness in a straight line. And a lot of first-time amateur astronomers run into problems there because they, they sort of have they find a series of dots, but it might go across and then down the long way. It doesn't actually satisfy all those criteria. And unless it does actually satisfy all those criteria, it's unlikely to be a comet. So that's where, first of all, a guide to educate the amateur astronomer is a good start. But then you can have a number of further tools, for example, where you enter in a series of coordinates and your computer checks to see that it is in fact going in a straight line, and perhaps if it can analyse the images, looks for the changes in brightness, and if they vary too much, it might say, look, this is probably not a comet. Ultimately, I think the best way to actually check it is to actually get other amateur astronomers to actually check a submission that somebody's put in, okay? Because they can then give feedback and educate. The more experienced amateur astronomers can educate the newer members as to, you're making a mistake here or here.
Great. Another question. We often say in the prize world and in the crowdsourcing world that you motivate people to participate in your activities because of one of 4 G's: gold, guts, good, or glory. And I wonder, from your perspective, when you look at obviously yourself, you're motivated to participate and do this in your free time for your own reasons. But I wonder if there's, going to a comment earlier that came in from Steve about whether or not there's more community building activities or kind of amateur to amateur connections that might be also another incentive that would get more people involved. Kind of pulling on that thread about what incentivizes amateurs other than being able to name it. If there's anything other than being able to name it, that's actually the stuff that causes people to spend their lonely nights looking at asteroids, as Carl would say.
I think that probably the sense of community does help. I actually have a similar experience, but not in the astronomer area. I recently participated in MIT's EDX program, where they're actually making a number of their units freely available for people to study online, and they have a whole social networking background, so you can basically work with other students and socially network as you're studying through the unit. And that whole experience, the social networking side of it, I actually found really, really good. And transferring that over into the the astronomy space, if there was a community there, and there is to a certain extent with the Sungrazer site, but if there was perhaps some really good social media tools there, I think that really does encourage the whole process.
Great. I think we have time for one more. Did you have a question?
Yeah, I really, really loved the video, and you obviously have a very talented daughter. One of the thoughts that occurred to me is that the number of asteroids to be discovered, there's a finite number. And so, have you thought of other ways? The naming is obviously the holy grail of motivators, it seems. But are there other ways that you've considered to keep people engaged? You stayed at it for quite some time till you were able to find one and then didn't get to name it. But one of the things I think we might discuss a bit tomorrow is badging. Have you thought of other mechanisms beyond just the naming of the asteroid that might help people stay connected and enthusiastic with this work?
Well, you can always offer prizes. I mean, if you're playing the astronomy space, and you've got people that are perhaps new to astronomy, then perhaps offering them, a chance to win a telescope, logically is something that is going to build on that whole experience and take them further into the hobby.
Great. Thank you, Peter, for joining us. We appreciate it. I know it's late there, so thank you very much for joining us.
It's early.
Oh, it's early. It's so late, it's early. Lynn loved it. All right. Well, thank you, Peter, very, very much for joining us. With that, is there another? Okay, so there was a comment online that we'll take real quick, and then we'll take a break. Go ahead.
So the comment was, it would indeed be nice to be associated by our names to the celestial object we may discover.
Yeah, so I had tweeted out, Peter, your question. I wonder what social media will say about being able to name asteroids, and it seems like we got a couple responses to it already. We'll see if more are coming in. You can follow that on the Asteroid Grand Challenge, Asteroid GC Twitter hashtag. So with that, we'll go ahead and take a break for 10 minutes. So if everyone could come back at 3:10. Am I in the right time zone? Yes, 3:10. Then we will get started with Jose from the Minor Planet Center at that time at 3:10. Yes.
Okay.
All right, so Jose, we're going to go ahead and get started in the second section here of speakers. We have a lot of focus on crowdsourcing this afternoon, as well as a presentation by the Minor Planet Center, which is largely the hub for most of the observations that are coming in globally for new asteroid observations out of Harvard. So we will have, or the Smithsonian Astrophysical Observatory. So next up is Jose, and Jose, if you will run us through your presentation in 10 minutes, and then we'll have about 10 minutes for discussion and Q&A for your particular set of ideas in response to the RFI.
Okay. So I think my webcam just went off. I don't know if you guys can see me, but I assume you can hear me. Okay. Can you hear me, Jen?
Yes, Jose, we can hear you.
Okay, let me get started then. So I am from the Scary Minor Planet Center, as Ray called it. Hopefully I'm not that scary, so let me quickly go through what the Minor Planet Center does. Let me get the slide up. So you can see here that we've been called the Nerve Center of Asteroid Detection in our solar system, and I think it was the BBC who said that in one of their documentaries, and it succinctly, I think, explains what it is we do. So let me go through this complicated looking diagram, but it's not that complicated, I promise. So let's start off with the surveys, top left hand corner, and they survey the night sky, and they're the guys responsible for discovering almost every near-Earth asteroid right now. So once they discover, or they think they may have discovered a new asteroid, near-Earth asteroid, they will send the data to us, to the MPC here in the center, and we will try to get a preliminary orbit, which is not very accurate, but is good enough, and we put it out in the Near-Earth Object Confirmation page, which is checked by surveys and amateur astronomers. And is a place where we say, here are these new objects that we believe are asteroids, and some of them are most likely near-Earth asteroids. Can you guys go and confirm this? So astronomers around the world check this out, this list, every night, and go and observe them. Then they send us in the data, we get new observations, and in some cases we figure out that this is a near-Earth asteroid. In other cases it's just a normal main belt asteroid. Either way, this makes it into our MPC database, and this data is then absorbed by, for example, NASA JPL or the Italian system NEODIS, who do their own processing with these observations. Other people also download it for their own use, and of course we then announce the new objects through social media and through the Minor Planet circulars. So the three most used services that the MPC provides to observers are the What's New, which is the NEO confirmation page I just explained, then What's Visible Tonight, where you can put in the information of where you are, and we'll tell you what asteroids are visible near Earth and not. And then the third service is, let me see, where should I point my telescope? Obviously, we can tell you what's up, but you need to know where to look. And you can put in a number of objects, or just one object, your location, and we'll tell you exactly where in the sky you need to point your telescope in order to see it. Now, the data that we get, this is information for 2012, so we received almost 8.7 million observations from telescopes around the world. Observers, almost 300 observers in 46 countries. And just like Carl's map, we can see here that there are a dearth of observatories in Africa and Asia. Now, the difference with Carl's map is that we do actually have quite an active community in Japan, and I think I'm seeing 6 observatories there that were active in 2012. But I think this shows that there's certainly a lot of work that we can do in trying to get observers from Africa and Asia to join the gang. Now, looking at the Pro-Am near-Earth asteroid observation statistics, this is for a 21-month period, more or less. we can see, hopefully you guys can see the numbers, but more or less, as far as observations go, about 2/3 are made by professionals. However, if we look at the number of telescopes, then we see that about 2/3 of the telescopes are amateur. So the numbers are skewed towards the amateurs for numbers of people that are looking at near-Earth asteroids, but obviously the professionals, which are mostly the surveys, are much more efficient. And if we look at the discovery rate, we see a little sliver there which you might just be able to make out, which is 3 NEAs discovered during this period by amateurs versus 1,670 for professionals. So most of the observations that we get are actually follow-up observations where amateurs do play a role. So one of the ideas that I've been thrown around, and which was my RFI response, was that of creating, for lack of a better name, near-Earth asteroid light curve core, and attracting amateurs to take light curves of near-Earth asteroids. And it seems like the MPC would be the best place to organize this from, or to be a node for this, because we are the people who announce new discoveries, because through the IAU we're allowed to designate them. So once we have a new discovery, or even before, if it's on the NEO confirmation page, we could alert the network of observers around the world. And I've taken the liberty in this map to add a whole bunch of new dots in Africa and Asia. And we could alert observers that are able to see these particular near-Earth asteroids from their location, and with the equipment that they have, they would produce the light curves, send them back to the MPC, and from there they'd be made available. And the MPC doesn't just provide observations, we do actually have a light curve database, and we would like to see it populated with even more light curves. Right now we have a little over 2,000 objects, of which about 10% are near-Earth asteroids, which is not a very high number. Now, I agree with what Carl said as well. He was advocating for having a central node where people could upload their data and have it analyzed in a homogeneous way, so that all the data is analyzed in the same way. And I think that makes a lot of sense. And again, if this were to be housed at the MPC, I think it makes sense. Now, the potential for citizen science, and this doesn't just apply to light curves, really be any type of observations that we're making of near-Earth asteroids with amateurs. The potential is large. We can engage universities to create student projects. We can convince amateurs that are taking pretty pictures to do science, because I think that we have enough pictures of the Andromeda Galaxy or the Orion Nebula. So get these people to use their very nice equipment to actually do science. We can convince amateurs that are already doing science, like for example those at the AAVSO that do variable star observing. They already know how to use their equipment and do science, then have them come do science for us. We can also attract people who don't have telescopes but who would like to use them. We can gain access to robotic telescopes, and this has already proved very successful. For example, the Fawkes telescope, where you have students in the UK, high school students, making observations and light curves of near-Earth asteroids. And there are people who might not want to be interested in observing, but they want to collaborate in some way. And Chris Lewicki, for example, will talk about one of their projects for crowdsourcing with Asteroid Zoo. And then there are also the people who just want to be evangelists. We at the MPC, we get emails every now and again from people saying, hey, I want to help out. I'm a teacher, or I work at a planetarium, but what can you guys give us? And right now we don't really have the infrastructure to provide material to these people who really want to help us in our mission. And the role of the Minor Planet Center, really it's the same role that we've always had. We've coordinated, collected, and disseminated data and observations for near-Earth asteroids. We also have light curves, and we're working on a new database that is going to supply physical characteristics of asteroids as well. So really the MPC is going to be your one-stop shop for asteroid data. So it would make sense that that our resources be leveraged for any type of citizen science project. my scary presentation is over, so I can take questions.
Great, thank you, Jose. All right, so we will take questions from the room and from social media. Are there any in the room to start? Nope, any in social media to start?
There are
Two that came in. One is a little bit more general. What are some examples of student projects?
So how do you engage the student community, Jose?
Well, that's not something that we have done, but like I said, for example, the Faulkes Telescope, that's Faulkes. If you look online, you'll find some of the projects that they've been running with high school students in the UK. I think there are right now I can't remember any other telescopes that are doing this, but I do know that there are more telescopes, like for example, the Las Cumbres Observatory network. They also want to provide this service. They have telescopes around the world, and that's very important that you have telescopes at night where in some other part of the world when the students are in school. But I think a Google search should bring up a few projects, but I think that we can do a lot more. There's not that much going on.
Another question for me, just how much data are we talking about that you guys have, and are you using the cloud at all, or do you kind of have your own server farm set up, or your own farm set up to do that?
Yes, we do. We have our own machines and our own cluster, and right now we have over 100 million observations. There are about 630,000 asteroids, and near-Earth asteroids we have 10,350, I believe. That's more or less the number that we have now. And like you saw in 2012, we received 8.7 million observations. And we know that some of the observatories are gearing up, like Catalina Sky Survey is going to be upgraded. Pan-STARRS should be dedicating more time to near-Earth asteroid observations. So most likely next year we're going to easily break the 10 million observations.
And at what rate are you discovering new ones? You said you had 10,350 in your database right now. When do you expect to hit 11,000?
So we discover in the last 3 years, it's been about 950 a year. And for next year, like I said, with the upgrades in some of the surveys, it could easily be 2,000 or 3,000 per year, new near-Earth asteroids that we discover.
Like on the slide that you have up right now, you have a NEA light curve core concept. Could there also be a NEA phase curve core concept?
Oh yes, definitely. The important thing that I didn't point out is that a lot of the asteroids that we discover them at their brightest apparition in maybe a decade or more. And I think Carl said that we need to observe them before they disappear. And that's quite true. If we don't observe them within a week or two of their discovery, then the next opportunity to observe them when they are as bright might be 5, 10, 15 years into the future or more. Hence the need to set up an alert system for observers so that on the night of discovery we can let observers know that they should go out and take a light curve, do phase curve, photometry, whatever it is they can do or are equipped to do.
Question for you, Jose. This is Jason.
Hey, Jason.
Hello. Next steps. What would you say would be the next things to do to get a light curve core going?
I think most of the stuff has already been mentioned in the previous talks. We need to get a website going. We need to have tutorials. We need to have a mentorship system. We need to make sure that people are taking good light curves. That, I think, is very important, and I'd like to stress that. We don't want to take Mickey Mouse light curves. We want them to be of scientific quality, and I think this is important for the people participating, that they know that they are actually making a real contribution by taking science quality data that can be publishable. And once that is set up, then we need to go find these people.
Great.
Hi, Jose, it's Carl.
Hey, Carl.
Hey. So one thing we really haven't discussed yet today, but probably is something that needs to be discussed, especially if we have an online GUI, is actual archiving of data. Because there's really no such thing as bad data, especially nowadays with all sky photometric surveys. Any part of the sky, you're going to have reference stars in it. Is that something the Minor Planet Center is thinking of doing? I mean, I know it's a lot of, we're talking a lot of data, but is it something you guys are thinking of?
So what type of data?
To archive the actual images.
Oh, the actual images? It's something that's been bounced around, and I think there's been a reluctance, historical reluctance, to archive images. It's something that maybe should be discussed, offline.
Yeah, I mean, it's something that going in the future with, the cost of memory going down shouldn't be quite as difficult.
It might make sense. Our position has been that we didn't want images because we wanted, let's say, part of the initiation process, right, is that the observers who take the images should be qualified enough to do the reduction and get all the data that they send to us. So we don't need to see the images. Now, like I said, this is historical, and what we couldn't do in 1980, maybe we can do in 2015. But it's not something that we can decide right now that I can tell you yes or no. But it is something that maybe we should discuss.
Right, because there's been plenty of cases where even I think Gareth went back and measured the original photographic plates of various asteroids back 100 years ago. So as we get new catalogs, it would be nice to be able to go back and actually, re-reduce all this data again at some point in the future.
Yeah, maybe it would. And I'll point out that like Herbs, we are taking the raw data. That is something that we actually do want, for sure, the raw data for the like Herbs, not just a spin period.
All right, any other questions in room? Nope. Okay, thank you, Jose, very much, and please stick around for the conversation that we're going to have later, the larger group discussion. Thank you.
I certainly will. See you later.
All right, next up, we should have Paul Cox on the phone. Paul, can you hear me?
Yes, Jen, thank you very much.
And Paul is with SLU LLC, and he's going to run us a bit through the work that they do to enable amateurs to make observations, and also some of the public engagement the work they do to increase public awareness of these observations as well. So take it away, Paul.
Thank you, and just a reminder, you guys are going to be moving my slides forward for me, so I'll tell you the next slide when I'm ready to move forward. But anyway, good afternoon, and thank you very much for inviting us back to participate in NASA's Asteroid Grand Challenge. Nice to be back. As you said, my name is Paul Cox. I'm a long-time amateur astronomer. And I worked with SLU since about 2004. SLU's lead tech, and I also co-host our live celestial broadcast. Now, SLU was founded in, I haven't gone to that slide yet, by the way, I will say. SLU was founded in 2002 with a mission to popularize astronomy. And since that time, our amateur astronomer members have taken over 2.4 million real-time images using SLU's patented technology. Now, I am going to talk about this slide now. We drive huge audiences for our live public broadcasts of celestial events, and the highlight of that, so you should be going back to the Google slide now. The highlight of that was our partnership with Google, and we had SLU's real-time images of the 2011 lunar eclipse fed directly into the Google Doodle on their homepage for 24 hours, so that's pretty cool. Now, I'm going to show you what we've been up to for the past decade, and you'll hopefully see what a perfect fit NASA's initiative is to our existing activities. Also, the systems and infrastructure we've developed, and the committed community of members who use the SLU telescopes. Next slide. Those telescopes that SLU members control every night are based here at the Observatory Del Tedi. It's a world-class observatory site, which is home to some of Europe's finest telescopes. It's located in the Canary Islands, and that means that the hours of darkness are absolutely ideal for
for US users. And it also eliminates one of those classic barriers to active astronomical observation in the amateur community. And that is, unless you're a pro astronomer, everybody else has to get up for work in the morning. Next slide. Now, on Christmas Day this year, SLEWE celebrates the 10th anniversary of our public launch, so we're very excited about that. And over that time, we have honed this robotic observatory solution that's proven to be affordable, robust, and is designed to be extremely scalable. Now, at the Tavy site, SLEWE's telescopes year on year have been more productive than any of the other facilities at that site. Now, you are on the correct slide now, so please don't move forward until I say next slide. SLEWE's members, they subscribe to the service, and the patented system deals with every aspect of the operations, from scheduling the missions, image acquisition by fully automated control of the observatory, also image reduction and processing all in real time, and the progressive real-time streaming to SLEWE members in what we call the mission interface. Next slide. Members not only watch missions that they've scheduled, but they can also watch and snap images from anyone else's mission. So really, SLEWE members were crowdsourcing long before the term became popular. And members use this incredibly simple interface to schedule objects from either a pull-down list of visible objects, or they can set up advanced coordinate missions. Next slide. Now, SLEWE's members have worked both individually and in formalized groups to follow scientific programs using SLEWE's telescopes over the years, contributing important data and measurements to a wide variety of institutions and professional bodies. I'm going to talk about that a little bit in a moment. Next slide. An incredibly important aspect of SLEWE's work is our live public broadcasting, covering just about every major celestial event, including what we consider our long and tenacious campaign to alert the public to the threat from near-Earth asteroids. And we've broadcast them live as they make their closest approaches to Earth, often within days or weeks of their discovery. Our program is being supported by experts such as Dr. Lucy Green, Duncan Kopp, and we also like to showcase the work and research of SLEWE members. And I'd like to give a quick name check to these few people. Excuse me for doing this, but Norm Pritchard, Dave Larkin, Christina Feliciano, Lerma Paul, Tony Evans, and Don Cranford all do a fantastic job. And we're able to attract sponsors to our events, and that subsidises the production costs, and that's a perfect fit. There was one example with the sponsorship of our 2009 lunar eclipse coverage by Paramount Pictures for the movie Transformers Dark Side of the Moon. Next slide. Actually, you need to go to slide 9 now. I think you're a little bit behind. Now, for some events, we call on our network of observatory partners around the globe. Many of those partners are motivated, just like we are, by their own outreach programs, and SLEWE dramatically increases their reach. And we're always looking for new partners. So the slide that should be up on the screen at the moment will be showing through. That's the one. Thank you very much. Anyway, our technical infrastructure means that our event partners can connect almost independent of whatever equipment that they have, and that's really pertinent for the NASA initiative as well. And showing these events live online has brought them to an audience that would otherwise have been left in the dark, literally. Next slide. We've built a far-reaching syndication network such that media websites now can easily embed our live coverage, and we've become the go-to partner for many of them, including ABC News, CNN, and a whole bunch of others. Because, among other things, our robust systems can usually be relied on to deliver, and we always try and provide weather redundancy when possible. Next slide. And because our coverage is live, our images and footage are often the first to hit mainstream TV channels. And that's been especially true of our near-Earth asteroid close approach shows over the last couple of years. So how can we apply our tried and tested systems and community to assist in the NASA Grand Challenge? Well, next slide. One area of our activities which has grown steadily over the years has been the number of members using SLEWE telescope to undertake various research and scientific studies. Many submitting observations and measurements night after night, year after year, to a broad variety of organizations and institutions, including, as we've seen, to the Minor Planet Centre. Now, it quickly became apparent to us that many individual members were tackling the same steep learning curves for many areas of study. So, together with assured support from several key and expert members, we formalised what is now known as the SLU Cooperative. Now, one member was particularly instrumental in setting this up, and we are watching now a ticker of his submissions over a 2-week period last year. And this is a very public thank you to Norm Pritchett, so thank you for that. Next slide. In addition to the normal nightly activities, SLU members have always been able to react extremely quickly to make follow-up observations of various short-notice events, not least because we have this huge number of members scanning for Astro News stories and alerts 24 hours a day. A fantastic classic example, which we really heard about actually on one of the previous presentations. Classic example was when we pointed the Canary Islands telescopes to be one of the few around the world who managed to image asteroid 2008 TC3. That was one 80 tons, 13-foot diameter, and we imaged it a few hours before it entered Earth's atmosphere over the Nubian desert in Sudan. And of course the entire SLU membership were able to watch the images in real time, so this is really getting it out to huge numbers of people. But that's only one example of so many. SLU members have notched up a terrific tally of pre-recovery, confirmation and other unique observations over the years. Next slide. Now, one of the key methods, and this is very appropriate to some of the previous presentations that we've seen, and one of the key methods we're developing to broaden this cooperative program is through a structured teaching and mentoring program. Now, members of the cooperative, they graduate to each level, and I think somebody else measured, maybe somebody has to be tested, and yes, you do, because you have to maintain your observatory's reputation. So, everybody participates in peer review of data and measurements to ensure that the reputation and the quality of our submissions remains high. And we aim to use the program to engage a wider community of amateur astronomers, extending our partnerships with astronomical societies not only in the US but globally. Next slide. Our cooperative program has provided a ready-made structure to service certain initiatives and projects, and one recent example of this has been the quantity and consistency of data we've acquired for Comet ISON. And we're currently working with the NASA-backed Pro-Am Comet ISON Observing Campaign to ensure that that data is utilized to the full, and that will be coming out later on this week. And we're always there to catch the unexpected, like this series of images showing Comet ISON and its temporary traveling companion is a near-Earth asteroid 433 Eros. That was a fantastic night. Next slide. So, astrometry, asteroid photometry and light curves. We've heard a lot about this already, and that's one new area of study and observation that we started a few weeks ago. Actually, it was just before the previous workshop was called. And we're forming a specialist group of members around that, and it's particularly pertinent, obviously, to NASA's asteroid initiative. Now, SLU is well placed to generate asteroid phase and light curves from both our existing site and from any partner observatory that could be adapted easily to use SLU's infrastructure. Now, this important aspect of asteroid study and monitoring is largely neglected, as we've heard, by the professional community, and that's primarily due to the fact that it swallows up a huge amount of time, and the PRO's time is actually usually, the PRO's telescope time is usually quite limited, whereas amateurs actually probably have far greater access to telescopes than the pros. Now, the light curves, as we've seen, they can take many hours for a single asteroid, so it really is best suited to a dedicated resource. By adding capacity to SLU's existing facilities, we could build a formidable and low-cost network of instruments dedicated to the task with a huge number of amateur astronomers at the controls. Now, using the same kind of training and mentoring that we've worked so well for the existing member groups, this task could be open to a wider dedicated team of citizen scientists very easily. A coordinated observation campaign would also dramatically reduce duplication of effort in the field, and with multiple facilities operating at different longitudes, it would be possible to acquire data for those asteroids with periods that really can't effectively be covered by a single station. Next slide. And this is another area where SLU's mature, cost-effective and flexible infrastructure could be applied towards the initiative. Now, what we do is far from easy, but we've developed hardware and software systems that can operate in the most severe environments. SLU could add capacity to our observatory in the Canary Islands, and we had consent and approvals to construct new observatories in both hemispheres, so we could bring new instruments online in a matter of months, not years. And don't forget, this is something that we're already doing. This is not a paper exercise. We're already doing this stuff. Now, the well-honed infrastructure, it could be adapted to accommodate the kind of advanced and generally underutilized amateur observatories that are being talked about by the other workshop participants. And it is really an incredible amount of equipment out there that just sits idle. And we found that actually a lot of people, they're not using it, not because of time, not because of a lot of other excuses, but they don't have a purpose. So if you give the amateur astronomer with that equipment a purpose to use it, they jump on it. So we were talking about the motivation, I think, earlier of citizen scientists. So all of this would remove a host of barriers that many amateur astronomers face when they try and set up their own observatories. High costs, poor sites, complex, time-consuming setup and operations, lack of expertise, the weather, of course, little support, no training, and no fellowship of like-minded astronomers to work with. And that's been raised as well. That's really, the community aspect of this is an incredibly big motivator for people to get involved and to stay involved. Next slide, and the last slide. So I hope with this we've illustrated that SLU's existing operations, infrastructure, public and media outreach all align perfectly in our eyes with many of the aims and ambitions of the initiative. And maybe above all else, we can make active and meaningful participation in the initiative accessible to huge numbers of amateur astronomers around the globe, removing all of the barriers that typically prevent them from pursuing their passion for science and astronomy. Now, we could utilize our real-world and tested, scalable infrastructure to place equipment at their disposal to monitor near-Earth asteroids from world-class observatory sites and elsewhere. And the structure of our self-supporting groups would provide the kind of hand-holding and training that really is required when people are first faced with the enormous steep learning curve when they start to undertake this kind of work. And last but by no means least, SLU, we can use our existing and extensive media and partner reach to publicize the initiative and showcase the achievements of the legion of amateur astronomers. We'd rally for the initiative. Anybody can contact me if they're interested in contacting me. They can just send an email to paul@slu.com and that will reach me. But thank you. That's the end of my presentation.
All right, so while we're waiting for other folks in the room who have questions, I have one. I know that you talked a lot, Paul, about the scalability of your company's system, which largely is a subscription model for members to enter a cooperative, pay an annual fee, and be able to reserve time on your telescopes for various types of observing. So it's for folks that don't have their own capable telescopes. They can pay a fee to get access to not only your telescopes, but also your processing software and a bunch of that, those other capabilities as well. You spoke a lot about scaling this model so more people can use it. I wonder to what extent the reliance on local astronomy clubs. It seemed to be that your one-to-one mentoring model relied on local astronomy clubs kind of buying in and signing on and wanting to actually focus on asteroid. I want to know a little bit more about your strategy to get those locals kind of enrolled. Is it a one-on-one, kind of going and talking to each of the local astronomy clubs? Is there a way to kind of tackle all of the ones in the U.S. at the same time? Kind of what's your enrollment strategy there when you're talking about scaling for technical assistance for mentoring to actually get more people observing?
It's not actually dependent on local astronomy clubs. What we found has worked, and our scheme at the moment, our mentoring scheme at the moment, people kind of aren't allowed in unless they promise that they're going to mentor at least two other people. So when they're up to speed on something, then they then take over two newbies coming in. So it's kind of a little bit like network marketing from that point of view. So it's not really reliant on local astronomy clubs at all. And frankly, when we get down to the bare bones of this, and especially when we're talking about specific scientific tasks, it actually becomes really quite routine, and it's not difficult to do. I know people have mentioned how difficult the MPC site is to use and stuff like that, but our members, frankly, as soon as their hand is held for their first couple of submissions, they're fine, and they're off. It really isn't as difficult as it seems if you're sitting there and you're facing those problems and systems alone.
Great. Other questions on social media?
I have a question, Paul. This is Jason. You've provided an incredible opportunity for folks that don't have the means to have a telescope in their backyard if, say, they live in a city. But for some people, there is still the allure of going onto the mountain and seeing the telescope. Are there opportunities for people to travel to the sites, to the Canaries, and either work there firsthand or see how the operation works from that regard?
That is such a pertinent question at this particular time. We've just signed a new 10-year deal with our partners at the site, the managers of the site, at the Institute of Astrophysics in the Canary Islands. And one of the things that we've been asking new members to tell us about is, would you be prepared to travel to a SLU conference? And it is something that we're actively looking at for 2014, to actually pull together groups of members who are able to travel to the observatory to get more hands-on. And that won't just be with maybe SLU's telescopes, but our new partnership and new agreement with the EAC means that potentially SLU members will have the opportunity of using some of the larger professional telescopes there as well.
On the media side of what you guys do, Paul, this is Jen again. On the media side of what you guys do you find that more often than not you're pitching your story to the Fox Newses and the CNNs and the MSNBCs of the world to get them to cover the live event, or are they coming and covering it on their own because it's of interest to them? Kind of how are you generating? What's your process for generating kind of the media coverage of some of these events?
Well, it's changed, Jen, over the last couple of years. I mean, we started trying to raise the profile of these things when I became more aware of how many of these near-Earth asteroids were being discovered only days before their closest approach to Earth. So we started covering these events, and at the beginning, we were having to really push for the media to pick up the stories. But as those few years evolved, and certainly this year, we've had some of the networks contacting us, asking us, is there anything on the cards at the moment? Because there seems to be a momentum with this whole story, and I think this workshop has obviously done that as well. But there seems to be a momentum in the media to follow up on this story. And one of our biggest challenges, I believe, over the next year is to maintain that momentum, to keep it, because what we did find is, I think there was one period earlier on this year where there were several very near passes by recently discovered asteroids within a couple of weeks. And we did find that the media were happy to cover the first, but on the second, the coverage went down. But we're in a period at the moment where actually there haven't been any recent close past asteroids discovered over the last month or two. We were hoping there would be, so we could actually bring you all live images of it tonight, but unfortunately they never cooperate like that, do they?
Right? It looks like we've got a question from Carl.
Yeah, speaking, since I'm involved with Target Asteroids, what is the easiest way to basically communicate with the members of SLU? Is it put out little bulletins that, hey, here's an object of interest, and would people be willing to observe it?
Well, we could set something up. The main way that we communicate at the moment is on our Facebook group, but there are other means that we have of producing pop-ups on the site, so anybody who's actually on the site watching live images at a time, we could put a pop-up in there, and they could immediately schedule a mission within minutes, Carl.
Okay, great.
Of like putting Chromebooks into grade schools and Macs into grade schools and stuff. Is there any effort to advocate this to school systems to generate observatory clubs in order to generate future business?
We have gone out to schools at various points, but it's been very, very difficult to generate the momentum in the school itself. Part of that is about timing. We really want live images into the classroom, so some schools in the States would have to stay a little bit late for that. But it is something that we are very eager to do, and in fact we've got a big initiative in South America to try and get SLU in towards the schools down there.
Great. Any social media questions? Good, Lynn? Okay, so thank you very much, Paul. That was great. We appreciate you taking the time.
Thank you very much.
And please, Paul, try to rejoin us in about 50 minutes after our last two presentations for the group discussion, if you can. Just call back in.
Certainly. Thank you.
All right, so now before we get into our last two presenters, which is Chris Lewicki from Planetary Resources and Andy Lamora from Topcoder, I want to welcome Lynn Bucco from the Center of Excellence for Collaborative Innovation, which is the organization for NASA that helps not only to run our own internal prizes and crowdsourcing activities that we do at NASA, but also acts as a center of excellence for the rest of government and helps the rest of government figure out how to do these new activities as well. She's going to give us a little bit more detail on something we're announcing here today, which is the first new partnership associated with the Asteroid Grand Challenge in the area of crowdsourcing and citizen science. It's actually being announced via press release in the next 8 minutes, both on NASA's site and on Planetary Resources site. So we'll tell you a little bit more about what this activity is going to be, what this partnership is. Lynn will talk a little bit more about what it looks like at a high level before Chris talks about it in much more detail, and then Andy a bit from the Topcoder angle. This is also to say that NASA wants to partner with a lot of people in a lot of different interesting ways on the Grand Challenge. So this is the first of partnerships, but this guy is looking for many, many space act agreements. So if other folks are interested in partnering with NASA on the Grand Challenge, we're looking to do many more types of partnerships like this. So please feel free to work with Jason on those. So with that being said, Lynn?
All right, well, let me add a little bit. Jen gave you the Reader's Digest version of what I was going to talk about, so let me get into just a little bit more detail. I have the distinct privilege of managing the day-to-day operations of the NASA Center of Excellence for Collaborative Innovation. That's a mouthful. We call it COSI. That organization is a true collaborative organization. The organization is supported by our Human Exploration Office, Jen's OCT organization, and the Human Health and Performance Directorate here at the Johnson Space Center. So as challenging as that makes my job occasionally to have three bosses, it is also part and parcel of the reason why the organization, I think, has been so successful. NASA created the Center of Excellence because of the groundbreaking work Dr. Jeff Davis was doing here at the Johnson Space Center, using crowdsourcing to advance efforts in the space life sciences discipline. And just to qualify a little bit, I love walking into a room where crowdsourcing is actually being used. There was a definition of it. For us specifically, I just wanted to refine the definition just a little bit, because for us, it really means we run competitions, challenges, contests. We kind of use those terms interchangeably and sometimes confusingly, I know, in large established communities where there is a vendor who curates that community, and we pay only the winners for the solutions that we choose to pay for. So when I talk crowdsourcing for COSI, that's the specific definition for us. While Jeff was down here doing this groundbreaking work in his disciplinary area, Jason Cruzan in the Human Exploration Office at headquarters, now our Advanced Exploration Systems Director, became intrigued by this practice of crowdsourcing, and he launched efforts to use it to address complex algorithmic data processing and software development efforts. Because of the highly visible work Jeff was doing and Jason was doing at headquarters, they were asked by the White House Office of Science and Technology Policy if NASA would be willing to create an organization to help other federal agencies capitalize on our lessons learned and our best practices, and if we wouldn't be willing to sort of enable their use of crowdsourcing to facilitate their mission. So they didn't have to reinvent the wheel. Believe it or not, the government really didn't want to reinvent the wheel. They wanted agencies to take advantage of this technique, to capitalize on it, and start using it and infusing it within their own agencies. So Jeff and Jason asked Bill Gerstenmaier, do you know who Bill is? Right. If he would support the creation of our little organization, and it's a little organization indeed. And of course, his specific question to Jason was, what does NASA get out of this? Jason eloquently answered that we get to learn from others' mistakes. That's always nice before we make them ourselves. And we can be so much smarter about how we use these techniques internal to NASA. And I'm here to tell you that we've learned a lot. We are now, as of this month, Space Station is 15, COSI is 2. We're 2 years old, we're out of our infancy and into our toddlership. So far, we have worked or are currently working with the U.S. Patent and Trade Office, the Centers for Medicare and Medicaid Services, the Office of Personnel Management, EPA, Department of Energy, and the United States Association for International Development, or USAID. But it's important and always important for us to come back to Gerstenmaier's question, because COSI isn't just about helping other federal agencies. Core to our mission is to ensure direct benefit to NASA and its projects and programs from the use of this, what I consider a really promising technique. And it is promising. I'd be happy to share more details, and I wanted to introduce Steve Rader, my deputy, sitting in the audience. If you want details of what specifically we've done with these other agencies, what challenges we've run ourselves, I'd be happy to share them. Jen is very eloquent in sharing what we've done so far. But I wanted to talk about one of the primary tools that COSI uses from its toolkit, and that tool is called the NASA Tournament Lab. The NTL was a result of a contract with Harvard University because we were really interested in furthering research in the use of crowdsourcing and open innovation practices, particularly in the software and algorithm development domain. Harvard established a subcontract with Topcoder, recently acquired by Apereo, who now has a community of over 600,000 developers that we can tap into. That's a large international community of coding talent who in large part share the common language of math. We're just finishing up 2 pretty exciting algorithm contests. One was for USAID and their tech challenge for atrocity prevention. It's been interesting to look at, as diverse as our government missions are, the application of this technique has had some pretty universal benefits regardless of what that particular mission is. USAID has in hand now 5 winning algorithms that will greatly assist them in developing the ability to actually predict the occurrence of human-induced atrocities. They went into this not really knowing whether they would get a result or not, and have been pretty excited about the outcome. NASA just ran a challenge called the Collective Minds and Machines Challenge that really was based on a lot of what you've been talking about here. The collective minds was humans who were looking at imagery of potential archaeological interest, and then figuring out how we could take that data set and apply machine learning to it. Harvard is still putting together the final analysis on the winning algorithms. We had 2, but in my extremely simplified version, we now have in hand 2 promising algorithms potentially demonstrating that instead of relying on 2.3 million imagery tags to identify specific targets of interest, the same result can actually occur with only 10,000. That's a pretty significant result. So, COSI is at its 2-year mark, and we build on these successes. And with that, it gives me great pleasure to announce that NASA has entered into a non-reimbursable Space Act agreement with Planetary Resources to develop crowdsourced software solutions to enhance detection of near-Earth objects. We're going to be able to apply what we've learned working with Chris Lewicki, and there is a lot of excitement around it. As Jen already announced, the agreement is NASA's first partnership associated with the Asteroid Grand Challenge, and it's really asteroids and near-Earth objects while you all are here. I want to thank Jen for the opportunity to talk a little bit about COSI, and I'm excited, and we'll get off the stage so Chris can take the stage and really give you some details about where we're going with this. We look forward to the success of this. We'll be working with Harvard, Top Coder, NASA, Science Mission Directorate, OCT. This is going to be an across NASA effort, so COSI's looking forward to making it happen. Thank you.
And with that, we'll toss it over to Chris, if you want to start your presentation. Thank you, Chris.
All right. Thanks, Jen. And thanks for the introduction on the Space Act agreement that we're underway today on, in partnering with NASA in using crowdsourcing to help identify even more near-Earth objects that are out there. So I wanted to give you a background of exactly what this project is. A portion of it involves work that we're announcing today with NASA. A portion of it involves work that Planetary Resources is doing privately with the Adler Planetarium in Zooniverse. And of course, this work wouldn't be possible without the support of a number of different places, which I will talk along the way. So ultimately, what we're interested in is discovering more asteroids, being able to track them more accurately, being able to do that more efficiently, and make the best use of the resources that we've had out there today so that we can apply new resources more efficiently. And despite all the progress that we've seen and the fact that 90% of the solar system has been discovered since the year 2000, most of this stuff happens pretty late, pretty close to Earth. It's not till they get close enough and bright enough that the surveys can find them, and of course this is as much art as it is science pulling this data out of the weeds. Most of these very small asteroids, like the one we experienced earlier this year over the city of Chelyabinsk, remain undetected, and there's a lot of work to go here yet. So how can we, for very little funds, just make an incremental increase in what we're able to do here and open up the potential for a lot of activity to come out of this? So we're in the crowdsourcing session today, and this is an idea that we came up with, which was a perfect application of the cognitive surplus that we have on the planet and the desire for everyone out there to help NASA, to help private industry, and to really help the world take on these challenges and do better than we've done to date. I was speaking with Tim Spar, the director of the Mount Ark Planet Center, about this project earlier this year, and also the work that Jose Galeche talked about today with light curves. And Planetary Resources was exploring what we might be able to do in this area, and this project really came out of that discussion. So we want to harness the crowd to find the gems in the data, find the things that the surveys haven't found. Machines, of course, are programmed by humans, and humans are fallible, but humans are a lot better at recognizing patterns than the machines are, and they're, of course, only as good as we program them to. As was mentioned with regards to the NASA agreement and what Lynn was describing is we're going to be working with the NASA Tournament Lab to have algorithm challenges, as has been done several times before with the National Tournament Lab, and we'll get into more detail on that. We want to improve the efficiency by reducing the false positives and increase the detection capability and the sensitivity of these data sets without really having to build anything new. And this is something that we can do because with groups like Zooniverse and other crowdsourcing platforms, there are nearly 1 million people who are doing peer-reviewed level of science on different projects every day. Probably the most famous of which in this area is the Galaxy Zoo, which has been a breakaway successful project. So the audience is probably very familiar with how it is that we detect asteroids, but I just wanted to give a basic review to remind you how this works. You're looking for things that move in the sky, stuff that are not static like the stars. So terrestrial telescopes and even space-based telescopes take several images time of the same patch of sky, and then look to see the objects that move. Algorithm is usually applied in this project to find the moving objects in this, and then a human operator really goes in and cleans it up. They verify what the algorithm found with high confidence. They can throw some out of the spurious data, and it's really their training, their intelligence, and their human pattern recognition that allows them to do that pretty quickly and pretty accurately. And ultimately, this data is reported to the Miners Planet Center, and they do the great work they do and report and collate these results and take into all the different factors into result and compute orbits. And the project continues every day of the week, every night of the week, year on year, until we find them all before they find us first. So a typical one of these pictures looks like this. I don't have the animated version of this up, but if it were animated, you would see a little bit less than 10 asteroids that are moving through the scene. And in many cases, the algorithm really finds all of them. But from a human standpoint, we could really examine this data to try and determine, is it complete? And that's really what we're going to be doing in the first part of this crowdsourcing challenge, which is the part where human eyeballs are going to look at data and find everything that there is to find. So the challenge is, in the overall project, is that these pipelines and the algorithms that are run to date are kind of conservatively tuned. We don't want someone spending all night throwing out 1,000 things that weren't an asteroid, trying to find the 12 that were, when automatically they might just be able to say 10, and they can find with 90% efficiency. So we tend to tune them conservatively so we can minimize the human's work. The code that's used in this, some of it is state-of-the-art, some of it's old, but in many cases it's drawn upon legacy astronomy code that was developed either for this purpose or for others, but as we know, code and algorithm and detection capability is evolving all the time. The other part of this is that most of this data is acquired, it's looked at precisely once by the algorithm and operator, and then it's archived, never to be looked at again. And occasionally we go back to a night to look at a follow-up, but for the vast majority of this data, it served its useful purpose in life, and it sits on spinning disks or tape or CDs. The process of analyzing this stuff is very compute intensive, and it's limited in its applications of how you could apply this stuff in space on a embedded system in a spacecraft. And then, as was mentioned in this session, the ability to access the raw data for others to take another look at it is not something that's openly available, and we would love to make this data available for everyone who would like to take a look at it. So the benefits of this is by increasing the detection capability, we can find smaller, lower albedo, darker, more distant objects. We can get faster analysis of global data sets by making it more compute efficient. Also, this improves space-based surveys by being able to get more of the good data to the ground and not send raw data. And then having this data online, of course, allows all the scientific inquiry that we can have with open data sets and access to that, especially with the computing capability that's available today versus 10 years ago. We've developed a list of science priorities between the Catalina Sky Survey team, from which we draw the initial data set, the Zooniverse team, and the Minor Planet Center, and I'll let you read through this ordered list. Primarily what we're interested in is completeness, making sure that we have a raw data set that can be used as the basis of an algorithm challenge, so that when an algorithm is testing against this data set, we know that what it's found is indeed something that's real and not an artifact that wasn't picked up by the original survey. There's a number of other opportunities that I won't go into detail today, but we have a poster at AGU coming up here next month that we can go into this, but just lots of opportunity by taking a harder look at this data. In the process of the Asteroid Zoo and other zoos that Zooniverse maintains, it's as much about the data set as it is about the people and the performance of individuals to perform the task you're asking them to, and having confidence that they're performing that task accurately. So Zooniverse is world experts in this training process in understanding human analysis and using kind of qualified humans to rank the other ones and say how well this is being done. But there's been many papers that have been published which have demonstrated that this citizen science and well-posed problems can yield scientific output that's every bit as good as the experts who did it originally. And the great thing about this is what we can ultimately do is free up those highly trained, very well-educated experts to work on even more difficult and more challenging tasks. The results that we're expecting by taking about 3 million Catalina Sky Survey images is to figure out what the actual complete detection efficiency is of that survey, one of the most prolific surveys on the planet, how much we might be able to improve it with better algorithms. We can work in areas where Catalina's algorithms are throwing out the data because it's difficult for an algorithm to involve. Treading losses is a common example of this, where the asteroid is moving through the scene too quickly. We can also try to figure out from the data set itself how many humans does it take to really verify this result. So a number of other things in terms of just educating people on asteroids and near-Earth object detection and how this science actually works, and perhaps inspire some people to take up this career in the future for students who are studying this. In terms of how we can leverage in the future, one of them is being announced today. By using this data set of completeness, we can then have algorithm challenges and work successive algorithm challenges to put better algorithms out in the field. Get a 5% increase in efficiency, perhaps, maybe a 1%, maybe greater than that, but be able to make those surveys perform a little bit better. Well, there's potential for integrating live data into this, where data could come off the telescope the very night, and people could involved in be verifying the discoveries that are made and reporting them to the Minor Planet Center. And other interesting projects like Project Snoopy is one of them that's being brought up, of finding the Apollo 10 lunar excursion module, and also linking all those one-night observations of things that were found but just weren't confirmable. The algorithm challenges, again, about efficiency, about detection capability, about optimizing these pipelines, and then also using this as a general purpose thing, not just for near-Earth objects, but everything in the solar system that moves. And Planetary Resources is interested in taking this technology not only to find more asteroids, but also to improve the ability of space-based surveys to make the most efficient use of their data pipelines back to Earth. So I'll close now. Just wanted to thank a few people involved in this, not only the people at NASA with Jen, Jason, Lindley Johnson, Lynn, and Jason Crusan, but also Steve Larson and Erica Christensen of the Catalina Sky Survey for graciously providing the data, Chris Lintott and Laura White from Zooniverse, Amazon Web Services, who will be hosting the Catalina Sky Survey as an Amazon public data set very shortly, and Tim Spar for ruling the solar system like he's always been done and keeping the data organized. So we're very excited to get this project started and off the ground. We're expecting to have some results here and have projects online here in just a few short months, very early in 2014, and hope this can be a model of great partnerships between NASA, the public, and private industry capability for solving the problems that we have in front of us today.
Thank you, Chris. So I can start with one question as folks in the room are thinking about theirs. For the benefit of folks in the room and also those online, can you also explain to us how this effort, at least in the Zooniverse effort, links up to some of the activity you had earlier in the year with Planetary Resources with your crowdfunding effort as well, just to kind of show the whole picture of a little bit of how you guys are supporting the Zooniverse activity as well?
Oh, absolutely. I forgot to even mention that. This was a project that Planetary Resources announced back in June towards the end of our crowdfunding campaign on Kickstarter with the Arcid Space Telescope. And part of the activity in funding it at Planetary Resources and also at the Adler Planetarium was funded by crowdfunding through Kickstarter. This was one of the pledge levels and stretch goals that we had near the end days of our campaign, and as a result of that, the Zooniverse team decided to take this project up, and we've been working on getting the project developed and incorporated in work that we can provide data for NASA as well.
So interesting models for fundraising that they've begun to experience. So another question, Chris. Additional data. You said that Catalina would start off the Zooniverse activity. Do you have any other thoughts about other surveys, potentially other data sources that you're thinking downstream might be plugged into the Zooniverse activity?
Absolutely. It's very easy to go to the JPL or the Minor Planet Web Center and look at the detection rates of the various surveys that are out there. Most of them, NASA funded them, some of them Department of Defense, and some of them private work. Catalina has been the most prolific, and the data set that we have to work with from them is about 25 telescope years of data, about 3 million images total that we'll go through and analyze. But things like Linear, Spacewatch, which actually ran its own citizen science activity, and were pioneers in this area very early on, is an opportunity for get to that data online and essentially prove this out with the Catalina data set. And then as we're able and interested, and if we have shown that it's producing good results, get this back on for other surveys.
Thanks so much, Chris. This is Jason. And in an effort of continual improvement, this is very fresh. But do you have a sense of anything that we on the NASA side that could have done better to make this easier? Thoughts on, as we move forward in additional partnerships, how can we improve from our end for folks that want to engage with us?
Well, I think as you had mentioned, it is very fresh and not quite first of its kind. But for us as a business and as a commercial for-profit company, it was kind of a new thing, both with our Zooniverse partners as well as with NASA. The Space Act process allows us to kind of work these relationships out and define the responsibilities, and I think in doing that, that was a very valuable thing for Planetary Resources to identify what NASA was going to take on and be responsible for, and where NASA was going to commit resources, and similarly where Planetary Resources was going to do the same, and where we each can bring leadership and capability and knowledge to the table to achieve what ultimately is a common goal as articulated in our Space Act agreement.
Great, thank you.
We have a question from social media.
Yeah, somebody is asking if you could provide more details on levels of partnership.
On levels of partnership, this might be a you question, on levels of partnership with the Asteroid Grand Challenge. So we can define levels how we want to define levels, because it's not clear in the question.
Yeah, I'm not sure I'm clear on what they're asking, but in terms of the Grand Challenge, really our first step has been to engage with communicating about what it is and recognizing that there are going to be lots of different people that can plug in that are going to bring lots of different resources. Here we see an excellent example of a Space Act agreement that has made it through the system, where we've been able to clearly identify areas of interest that overlap, and the parties can come together to get to that future that we share. I'm sitting next to the Prize and Challenges lead, and I anticipate that there's a future there as well, where a level of partnership could be a prize or some incentive that brings people into this. And so at this point, we're really wide open in our conversation. We've heard a number of great presentations here in the crowdsourcing discussion already, and in terms of getting amateurs engaged, I think it's been clear that one of the things that NASA can bring usefully is our brand and some of the science and technical expertise. And part of the question I was asking with Chris was, how do we not slow people down? Because that's one of the things I heard this morning in the partnership and participatory engagement is our processes can be slow and government can move at a pace that's a little different. And so that's going to be one for us to explore as we move forward.
Mm-hmm. Any other questions for Chris? Yep, in the room.
So given your long-term goal of actually finding resources on an asteroid, how do you see extending what you're doing here to help you enable that?
So part of this is for the specific goal of finding more asteroids and finding more potential targets and understanding their orbits in higher precision. But part of it also is about understanding this technique for solving problems as a generic tool. Using the best minds on the planet to create the best algorithms to do efficient things with software, with computers, and with robotics that allow us to achieve our goals. So this is a bit of a pathfinder for what we're doing, and I anticipate that we will do a number of things like this to engage the broad community. I think Andy is going to give you some more detail from a top coder perspective on how challenges like these actually work in finding the best algorithms and the best coders out there. So that's in part how it helps us to start achieve our objectives. As is often said, you can't go and mine an asteroid unless you know where it is, and we have a great database to start with, and we'd like to make it even better.
I have one additional question. This is both for Chris and for Lynn, just because I want to make sure I remember correctly. The algorithms at the end of the challenges, is the intention to release these open source, or what happens with the algorithms at the end? Yeah, and Lynn says in the room the intention is to release them open source. So this becomes an important thing for those other folks that are interested in increasing the detection efficiency of surveys. The point of this is that it's that algorithm becomes a public good.
Yes, and this is released via GNU licenses, GPL type information, the algorithms, as well as the data associated with the surveys.
Thank you, Chris. Any other questions in room? If not, we'll move on to Andy. Nope. Thank you, Chris, very much. All right, we will move on to the last presenter right now, Andy Lamora, who's with Top Coder, who, as Lynn had mentioned earlier, is one of the subcontractors that we work with through the NASA Tournament Lab that will be working with us on this particular contest-driven algorithm development activity. He's the last presenter of the afternoon. We'll take a quick break, and then we'll come back for the general discussion for the remainder of the time. And I would like to propose that we maybe move our chairs into a circle and have more of a discussion for that point, so it doesn't feel quite so auditorium style. And we'll finish it off having a discussion about filling the gaps on some of these presentations, synergies between some of the ideas, and figuring out potentially ways to move forward as a community. So with that, Andy, can you hear me?
Hi, Jen. Yes, I can.
Okay, can we turn up Andy's volume a little bit? Great. All right, Andy, I'm going to toss it over the fence to you.
All right, thanks a lot, Jen. And it's obviously wonderful to be here. We're really honored to be able to speak to such an engaged and interesting group. I'd like to also echo what Lynn Pico had said earlier, that walking into a room and finding that there's a ready definition of crowdsourcing is both extremely welcome and a little surprising. It's not what we're always used to. As a result, some of my slides are probably a bit more high school level than this graduate level crowdsourcing class, so I'll try to skip over them as quickly as I can. But without further ado, let's jump in. As Chris said, I'd like to talk a little bit about how we handle crowdsourcing, because I think we have a slightly unique take on it from what you've seen before. And let me try advancing a slide here. Now I have someone to advance this up. Never mind, I have it right here. Thank you. I have to mention first, of course, that you may have heard, and as Lynn alluded to, Top Coder in September was acquired by Aperio. Aperio had an existing crowdsourcing company called CloudSpokes as a subdivision, which ironically had been developed by former Top Codians anyway, and the combined community is now just shy of 600,000 contributors. As a practical matter, it doesn't have much effect on what we're doing with NTL, except that it does bring additional competencies to bear, especially in cloud and service-based technologies. So my general theme today is to talk about community by community. To us, this is the concept of using one community and directing and channeling it through incentives to focusing on a problem that might interest another community. So how can you seed one with the other? First, we'll talk a little bit about how Top Coder does things, crowdsourcing in general, accomplishments and contests, just to kind of build to the case of how we use these to work with crowdsourcing in communities in general. And then let's apply it. Let's talk about what we can do to advance asteroids. So, what is Top Coder? So Top Coder is a large community. It's 592,000 people worldwide, all interested in design and development in some manner. So we have front-end design, so people are doing graphics, like, for example, this slide. folks who are doing development, everything from software to mobile applications, software as a service like Force.com, to algorithmics and analytics, and to people who are not represented on this slide, but who simply come here to have fun. They join TopCoder and work on 3 90-minute, extremely difficult word problems in competition with each other in the middle of the night, and they call that fun. TopCoder approaches a project or a challenge, and as Lynn said, we kind of use them interchangeably. To us, a challenge is something that you want to accomplish. We approach them by breaking them down into a lot of constituent interest areas. We call this atomization. We do it because we have found that the best way to attract people and engage the interest of people who have cognitive surplus is to do it in a spot where they have a sharp interest at a certain time. For example, as a practical matter, it might be difficult to find somebody who's willing to build an entire mobile application that's able to integrate 4 or 5 different data sources, provide augmented reality, and look beautiful and be easy to use for a couple $100 in a week. But you can find somebody pretty easily who's really interested in doing something that's beautiful, and another person who's really interested in doing something that's wonderful code, and yet another one who's very interested in data sources and figuring out how to get them to synchronize. So if you can break your challenge down into many constituent challenges, you have a much higher probability of having a sustainable outcome. You might once or twice get the moonshot, but having a sustainable outcome both in algorithmics and in regular old software production requires this sort of approach. If anybody has more questions about this, feel free to ping me afterwards, and I think we'll make this presentation available. We're often asked if you're running a contest, how do you decide a winner? Real briefly, because I think it will play into what we're going to talk about in a few minutes here. A very subjective contest can only be judged subjectively, so you pick it. But a software contest, it gets increasingly deterministic as you work with requirements. I want this thing that does that thing this many times in that amount of time with this much space on the screen. In that case, it's subjective. We score things on a scorecard. And then you get to algorithm contests and analytics. Our take on running a marathon, what we call a marathon challenge, but an algorithm challenge, is not to have an open call and ask for the best. It's to develop a scoring algorithm that weights the objectives that we're looking for and to build a leaderboard around it. So over a 2, 3, or more week period, contestants are submitting code that's actually run and compiled by TopCoder, and they receive a score that the world can see on a ranking that the world can also see. So you're kind of hitting the 4 Gs that Jen had referenced before. You have guts just to take on a problem, like find a better configuration for the solar panels on the International Space Station. Gold, because there's 30 grand at stake. Grit, because you're helping the ISS. And glory, because you just solved the problem on the ISS. Let me move things along here. I'll skip this slide in the sense of time. Okay, this is probably preaching to the choir, but we'll cover it anyway, just to make sure our terminology is the same. As everyone's probably familiar, a lot has been accomplished with crowdsourcing in the last couple of years. Some very notable examples, of course, are Linux, Java, Wikipedia, Phonebit, and National Geographic. The National Geographic Field Expedition in Mongolia is the project that Lynn was referring to earlier, and that'll come back to us here in just a minute. Linux, I think everyone's probably familiar with, but Java might be a surprise. This is one that was begun by fun, but was amplified by a crowd. So too have things been accomplished with contests. Some famous and maybe some surprising examples include the longitude contest in the 18th century. The British Parliament put a 20,000-pound prize up for anyone who could figure out how to determine your longitude at sea so that they would stop losing entire fleets. The fellow who won it was a cabinet maker who knew the value of having, of understanding how wood works and keeping a chronometer steady so you'd know where you were at sea. The White House portico was designed through a contest that was hosted and judged by none other than George Washington. Canned food was developed by a contest hosted by Napoleon, who was very concerned about how to feed his troops. You have Lindbergh's Flight and Sorry X Prize, and maybe one or two things on top of her. There's been a lot of academic research about this, and I can make this slide available for anyone who'd like to find it, but it's a hot topic and under a lot of study right now. So how does TopCoder look at this, and how is this going to help in crowdsourcing and community science? We'll run through a few examples. Lynn touched on this one. We are a subcontractor to Harvard Institute of Qualitative Social Science and serve the NASA Tournament Lab. Through them, we've developed an iPad application for use by the astronauts to track their diet on the space station. We've developed an image processing algorithm to determine if there are any threats near an oil pipeline. And we developed a web-based API, a RESTful API that integrates the federated data systems for planetary data services. On top of that, we also built some applications that demonstrate its utility. And of course, back in the spring of this year, we ran a marquee challenge for the International Space Station to determine optimum configuration for the solar panels that minimized shadowing. So the point here is that it's a very broad spectrum of questions that you can ask a community, even one that is engaged with math. Here's one that's perhaps not that surprising. This is a challenge to improve the performance of Megablast. The green M is what the NIH has achieved. The blue F is what an Oxford-trained MIT graduate PhD postdoc was able to achieve in about a year. And the red dot is the TopCoder result in the 2-week contest for $6,000. So some surprising outcomes can be achieved with contests when you can attract crowds who have an interest in this. You can even work on problems in Medicaid and Medicare.